Welcome everyone to our workshop, Building a Decision Augmentation Platform to Address Global Issues. My name is Bobak. I'm the CTO AI for Cognizant, and just wanted to welcome everyone. We have a little bit of a logistic issue, as is usually the case with these workshops. People are still kind of signing up and trickling in, but just to keep on time, we're already kind of 15 minutes late. So we're going to kickstart it. It's being recorded. We have folks online as well. So if anyone missed the intro, they can always rewind and watch the recording. Yeah, so this workshop, if I can advance the slides. Yeah. So this workshop is basically around a project that kickstarted a year or so ago for the same purpose, which is creating a place for global teams from around the world to coalesce on solving problems that obviously they will have been focused on locally, but they're global problems and they have global manifestations. We're going to talk about some of our findings, some of the work that we've done so far, but this workshop is really about working together, discussing requirements, coming up with ideas. We have some actions out of this workshop, so it's not just the basically write-up of what was discussed, but also some actions and timelines. And most importantly, we're looking for help and we're looking for volunteers. We've set up the workshop in a manner where in the morning sessions, we're going to set the stage, kind of level set on what we're out to do and what we've achieved so far. And so to that point, to that end, we're going to have Risto Mikalainen, who's part of the project, talk about the history of the project, even give you perhaps a demo and talk about the goals of the project. And then we will have some keynote presentations. We have a couple of people dialing in remotely to do keynotes and a few of us here. And this hopefully will give you an overview of not just this project, but similar projects that are out there, the data aspects of it, the architecture aspects of it. And, we'll also give you a first sneak peek at some of the work we've done on the MVP project here. We will have breakout sessions after the break. We have 2 rooms outside, so we're going to split people into 3 groups. It's going to be self-select, so depending on which topic is more interesting to you, you're going to end up in one of those 3 groups. Not sure what to do with the online folks, but we'll figure it out. In those groups, we will have a lead, and we will also identify someone in each workout group that will then report back in the session after lunch on the findings of the workout, on the breakout session. After that, we're going to have a fun little post-it session. So if you are split and don't know which one of the 3 breakouts to go, no problem, because in the post-it session, you'll get to actually contribute to all 3 tracks. If you have new ideas, there's actually a 4th post-it where any other ideas, thoughts, feedback can be posted on there. And we'll sum it all up and close it by around hopefully 2:30 or 3 o'clock. Just a few points on logistics here is that if you're, as I said, we're going to try to make it very interactive. If you have questions or comments, please turn on your microphones if you're in the room. That's the only way the folks online are going to be able to hear you. And then please turn it off afterwards. And then the second thing I wanted to say was Andrea and Martin are going to be here. Andrea's sitting right here. Not sure where Martin is, but they're local, so they know the ins and outs of ITU. And if there are any questions about where to go, what to do, they will be able to help. For the coffee break, as well as the lunch break, it's every person for themselves, basically. But we would suggest going downstairs to the cafeteria. We don't have, in Europe, we don't have a first floor, do we? The first floor. It's all so confusing. The ground floor, yes. And there's a cafeteria there, so we can go there for lunch as well. We can go to the cafeteria. And for the networking reception, there is a cafe outside. I forgot the more details. Yeah, we'll give more detail on the cafe a little later. So those are just a few words there I wanted to give. I also have Amir Bani Fatimi here. We're very privileged to have him on board. He's one of the founders of Project Resilience and a founder of AI Commons. So I just wanted to pass the mic to him to just welcome you guys.
Thank you, Babak. Can you hear me okay? Wonderful. Thank you, be here. This project started about 3 years ago, in essence, when we noticed that a number of organizations and people around the world are trying to do something for COVID. And that something was about creating prediction about what to do, how to protect people, number of deaths, mitigation factors, and so forth. And then observing that, we thought that maybe the best way to do is to figure out an environment where people can collaborate while they're working on different ideas, different build-up, different software, different machine learning approaches, how they can actually all coalesce, and we can create an open source environment for that. So we launched this with Babak and Risto and Cognizant and some of the partners and Oxford University as a global competition called, at that time, what was the name of the competition?
Pandemic Resilience.
Pandemic Resilience. And we had about 140 teams around the world that were basically trying to come up with a predictor and a prescriptor. The predictor was a way for all the participants to predict the outcome of COVID. And the prescriptor was a way for policymakers and decision makers to have a way to interact with the prediction and to promote some mitigation factors. That project was successful. We got 2 winners, but what came out of that was that everybody's working collaboratively, and the open source methodology can apply with this project. And how can we create now a more general approach that could be standardized, where we can share data, or we can all the teams can work on a common core platform where decision makers and everybody will have access to a cloud-based decision making support. People, for instance, in some countries don't have access to data scientists. So when it comes for hurricane or COVID or other economic issues or any outbreak, how they can prescribe mitigation factors, what data they can use. Well, if you don't have the platform and the decision makers and the data and the data scientists, is there a way that you can provide them an online platform to do that? So this was the foundation of this project. And then we decided to put this project at Project Resilience. With the help of ITU, we think that there's a number of standards, potential standards lying in this, in terms of data sharing, prediction methodologies, cloud-based decision-making processes. And this is where we are right now. So the first instance was on pandemic. And now we're trying to also demonstrate today the use on climate change and land use. You're going to see the demo. But the overall project is to create a collaboration environment where we can all work towards more readily accessible common core decision-making platform on the cloud for people to use. And that is a hard engineering problems because it's not easy to make available to people that are not data scientists, and is a way to manipulate data and to understand how to make decisions, how to mitigate. So welcome for today. This is going to be interesting. Your participation matters because this is mostly a group of engineers and data scientists working on this, but we try to also to work with political scientists, psychologists, social environmentalists, and others to create a framework. And Guillaume, which is here also, will talk about the data sharing aspect of that, because the more data that we have, the more we can actually improve decision making. But not all data is always available. So how that we can promote and incentivize sharing of some data under the rules, right, of consumption, so that those decisions benefit the majority of the people. So welcome again today, and I pass it on to Risto.
Yeah. Let me share my screen.
You might want to turn on your microphone, please.
Oh, it's at the wrong side. And that's the camera, I believe, right?
Yeah.
Okay. Okay, strange setup. You have to stop sharing apparently. There you go. Okay. And we'll share here. And I think if it's hard to hear in the back, you can close the window. I did it here and you know, the traffic noise goes away. It's much easier to hear. Okay, it shows up. Yeah, so I'm Risto Mikkulainen. I'm a research lead at Cognizant AI Labs that Babak is leading, and also a professor at University of Texas, Austin, in computer science department there, work on AI. In Cognizant, as Amir mentioned, we started right when the pandemic started to think about what we could do about it in terms of AI and machine learning technology that we had developed. And within months, everybody got together and put together this demo on decision making, optimizing the mitigations on the pandemic using AI. And Elliot Mason, my former student, who's a researcher, was there. Olivier, the lead architect at Cognizant, as well as Elisa Ganzani, who's an epidemiologist background, and Darren Sargent, the developer. We all worked very intensely for a few months to put together the demo that would show you what AI can do in this domain. So that's the really origin kind of this whole project where it started. Pandemic was a tremendous, sort of like a war. I mean, it instigated a lot of research and progress within a few months, and this is our contribution to it. Now, I think Amir already described what happened next. He found out about the project and we talked, and he was very nice in order to sponsor an X Prize competition based on this same platform. So that was the next big expansion of it, expanding it to the whole world, not just putting a demo on the web, but getting people involved. And there were several people from X Prize that contributed that. Too many to list here. And then in that same kind of stream, the next step is the project resilience, what we're going to talk about today here. The workshop is all about how to take that even further and not just limit it to the pandemic, but actually provide a platform that would cover other societal challenges using the same kind of technology. So that's a timeline, that's the origin. And I'm going to briefly talk about what the technology and the contributions were that went into that. So let's start with, we had developed already at Cognizant this model of optimizing decision making, which is based on two models. There's a predictive model that a lot of people use all over the world. That's what machine learning is mostly about, that you have data and you learn to predict what will happen in a new situation in the future. And to that, we added another component, a prescription component, not just what will happen, but what we should do about it. Coming up with decisions, actions, mitigations based on the predictive model. Because it's sometimes difficult to test things in the real world. We want to test them a lot when we are actually discovering good things, but effective solutions. That's why we need the predictor. We ask the predictor, how good is the suggestion that AI came up with? And that's the idea. In the case of the NPI, non-pharmaceutical interventions optimization, the predictive model is trained to predict the cases. So it's given a history of cases and the interventions, and it predicts how the cases develop. We also know how expensive the NPIs are, like economically, how serious they are, how stringent they are. And then the prescriptive model, given the same history of cases and interventions, tries to describe what would be the optimal way of going into the future, what interventions we should have. So here on the right, we see both the prediction of cases and also the history and the suggestion of what we should do in the future in terms of this color encoding along multiple dimensions of possible interventions: school closings, workplace closings, public events, transportation, international controls, masking, testing, all of those dimensions. Okay, so that's a general setup. We already had this model, this approach, evolutionary surrogate assisted prescription, and we applied it to the pandemic domain. And the reason why we could do it was that there was data available. I mean, this is like the first pandemic when there's real-time data coming out on what's happening in the world. And there was a project at Oxford that we'll hear about in a few minutes. Toby Phillips is going to talk about their project on putting together that data set, actually collecting not just case data, but also action data around the world, what governments were doing. And that data was available so we could use it to train these models. This is a neural network model, LSTM-based model that gets us history of cases as well as history of LSTMs. From that data set, we trained it to predict what will happen in the future. So this is different from standard epidemiological modeling, SCIR modeling, which is 100 years old, developed in the previous very serious pandemic, based on differential equations, mathematical modeling. This is database modeling. We don't necessarily know what's going on underneath. We just look at the data and the neural networks learn to predict and prescribe. So in that sense, it's a different kind of an approach that most everybody was using. And it's also different because it comes up with prescriptions, not just predictions. Okay, but the promise is that when you're looking at just the data, you don't have to put in guesses. Like SCIR, you have to guess the R0, the transmission rate, many times over in all the countries, under all conditions, all MPIs. Very, very hard to do. We tried to do that, but it turned out to be too slow, too difficult. So the data was a better plan. Well, at least it turned out that it was a good plan. We didn't know when we started, but it turned out that data was sufficient to do this. So once you have the predictor, then you can evolve the prescriptor. And that's a little different because we don't know what the optimal answers are. Like in a prediction, we know what happened. Weather prediction, stock market prediction, you have the whole history of data. You can train it, the supervised training. For this situation, this is the right answer. For the prescription, we don't know what the right answer is. So we have to find it by exploring, trying out things, seeing how well they work out against the predictor. And then we reward those that are working better than those that aren't. And we're using this method called evolutionary optimization to do it, a population-based search. You have a whole population of candidate prescriptors, and then you evaluate and find out which ones work. You keep those, recombine, mutate, have a new population. And it's like a model of biological evolution, a parallel population-based search. Now, it's also multi-objective because you want to minimize cases, but you also want to minimize economic impact of the MPIs. And therefore, what you'll get is a Pareto front, a collection of trade-offs. Your population actually organizes along this Pareto front. Some of them are really good at minimizing economic impact. Others are really good at minimizing cases. And then there's all these trade-offs between them. And that's what decision maker can take a look at and decide what he or she is willing to live with. How many cases are tolerable in order to minimize economic impact? And that's what you want to give the decision maker. AI does not tell you what the best policy is. It just gives you the best possible trade-offs of those policies. Okay. And indeed, the system did discover all kinds of interesting solutions, predictions, as well as prescriptions. Early on, it focused on schools and workplaces, discovered that it matters what you do in schools and workplaces, the top two lines here in terms of restrictions. And indeed, a couple of weeks later, papers started to come out suggesting that you should really care about schools and workplaces. That's when people are indoors with other people 8 hours a day, and that's when most of the transmission happened. By the fall, actually, it was a little less important because people had learned to alternate. They had learned to, work from home, and kids were at home. And also at schools, they started to build ventilation and little enclosures and other things. So it was less important at that point. And then the model started to focus on gatherings, travel, and other aspects of the MPIs. One big thing I'm going to show is the Delta search in India. By March of 2021, Delta variant had already emerged, and we'd seen it all over the world in a couple of places anyway. And our models were predicting a huge surge in India, like something really bad is going to happen. We didn't believe it. There was no reason to think that this was going to happen. But it turned out that the models had learned about the Delta, and they saw just an inkling of it in India and predicted a huge surge. And that actually indeed did happen. And it was predicted early on that, it could have been possible to do something about it if it had been possible to communicate with decision makers and convince them that this is going to happen. Now, in August the same year, we actually had a chance to talk to a government, not India, but much smaller country, Iceland, but they actually listened all the way to the prime minister. They were asking for advice on how to handle the opening of schools in the fall of 2021. And they actually looked at the models. They were shown in national TV. They went to the health minister, and I've had a collaborator there from academia who had these contacts. And it actually worked. And that was nice to see. Even if it was just one case and small case, that it can be done. You can communicate to decision makers and have a positive effect. Limitations. In December 2021, we missed the Omicron surge. That, unlike the Delta, Omicron we could not predict. And that's because it happened everywhere at once. There was no data to see it in some countries and predict in others. It happened everywhere at once. The model couldn't quite adapt to that. Last suggestion was the masking still in 2022. That was the last thing that kept coming up in the models as an effective mitigation. So you can see that there's quite an interesting collection of suggestions, and it changes as the pandemic changes. That's also important. I mean, the pandemic wasn't just one thing, it was multiple variants, different behaviors. People got tired. Some places they obey the rules, and other places they don't. And when you base everything on data, you actually don't have to understand all of those and describe them. The models actually adapt to them over time and in different geos. And that was really nice to see. We're still analyzing all the data that came up like everybody else in the pandemic, but it's quite promising and a nice use case of data-based decision support. All right, so I can give a very short demo. Do I still have time for this? It's actually pretty short, and I have it already ready to go here. I just have to share, new share. So this system is actually on the web, and you can go and interact with it yourself. That's the URL, evolution.ml, and you'll find it easily. It is interactive in that you can go and you can look at the model in different locations in the world at different points in time. Oxford completed the project by the end of 2022, so it's now frozen. There's no new data coming in. But while it was happening, when the pandemic was running, we rerun the models every single day. And that's how you adapt over the pandemic. But now it's frozen, but you can still go back to an earlier date. This is March 1st, 2021. And you can pick a country here. Almost everywhere. There certain countries didn't report, but most countries did. And I picked India. Here you see the Delta search. This is the actual search.
Yeah, I think it's lagged.
Oh, that's interesting. It does share the window. Oh, there you go. Wow. Yeah. I mean, I'm showing what I need to show, but it's not showing.
I think it caught up.
Not quite. Yeah, so we see the countries and we can see the case predictions below it. The purple line is the actual Delta search. As you see, it's huge. And then there's the recommendation of the AI in the dotted blue line showing what could have happened if we had actually followed the AI's prescriptions based on the predictive model that we had. And you can see that it's actually quite nice. It avoids much of the peak. You can also pick. Oops, I have to share again.
It's not connected.
Ooh, okay. So it looks like the Zoom went out.
You just
All right, let's start. I have to find where it is. The link here.
connection problem maybe.
No, let's try Zoom. Zoom is still running. It's just that I'm not connected to it.
It's still running.
Connection. Where am I? I am at ITU Wi-Fi, but it's not connecting. Okay, I'll try disconnect from the Wi-Fi
Yes,
and
can-
reconnect.
yes, please.
Other than that, I have to reboot.
I
The
guess
only
it's
thing
because
left.
this is locked connection.
Okay, let me
Can you
just,
close the connection here?
well, I'm just gonna restart. Yeah, there you go. Network connection failed. Okay, let's start Zoom. Again, I have it here. I think it's coming up now. Everybody else is connected? Okay, I think it's coming back up. Weird. No, I don't want to update terms of service. It's just really slow. I'm sharing, but it's not showing up.
You're connected. You're sharing your camera, yes.
Share the camera. I'm actually sharing the camera.
Shared here.
Oh, it's showing PowerPoint slide, but it's not sharing it.
Can we try the desktop one? Again, is it?
It's not updating it. Let's try to share screen again. Where does it see the PowerPoint? Ah,
No other.
I think we can do is we can come back to that demo because
it's not the demo. I mean, I can't share anything.
He can't share.
But
Let me check if
saying for the interest of time, we can go to maybe the keynotes and then come back to so.
Yeah, I think that might be a good idea. This is just not working at all. We have to reboot. I mean, I don't see anything else. Yeah, so
Excuse me,
Yeah.
you're not connected to the meeting.
not connected,
No,
not right now. It just kicked me out.
yeah.
Let's see if it comes back. I'll try one more time, Zoom. And restarting it, and then we'll have to move on. That's quick to do. Okay. Restart Zoom.
Amir just had an idea to, as part of Project Resilience, collaborate on fixing AG instead of fixing.
Yeah. You know, let's move on with Toby's presentation, because this is the data that I just talked about, and he can give his presentation about the Oxford project on the data collection. I'll try to fix this and then continue my presentation after that. It actually fits in just fine. So why don't we do that? I don't know if
Yeah, Toby's on.
Toby's on, and yeah, so Toby Phillips is the executive director of the Oxford project on collecting the data for the pandemic from Blavatnik School of Government. And he's going to talk about building data products in the pandemic perspectives from the Oxford COVID-19 project. So go ahead, Toby. You can share your screen and.
Excellent.
there you
Thanks.
go.
Thanks for the introduction. There we go. And yeah, real pleasure for me to be able to join you. I'm coming in from Melbourne, Australia. And as Risto said, I'm the executive director of the Oxford COVID-19 Government Response Tracker. And I assume everyone can see the slide that I've got up there, but just yell out if there was any issue with the screen sharing.
We can see it, Toby. Thanks.
Perfect. So let me jump right in. This is a brief outline of what I'm planning to run through in the next 20-25 minutes. So my main focus will be on really the process we went through to design a data product, collect the data, and then, you know, the infrastructure we had for publishing it and getting it out in the world in real time, as Risto was saying. So before I jump into those substantive bits, though, I will just kind of give you, for those that aren't familiar, the quick intro to what the project actually was. So the Oxford COVID-19 Government Response Tracker, or the OxCGRT, produced a systematic data set about COVID policy. So we started right back in March 2020 as a bit of a side project of a few of us at the Blavatnik School of Government. You know, being a public policy school, we were interested in government responses. And if you can cast your mind back to February and March 2020, governments were doing all of these very novel things, like, you know, closing schools, contemplating stay-at-home orders, shutting down public transport. It was pretty unheard of. And so we had a whole bunch of research questions that we wanted to answer about these novel actions that governments were taking, but we didn't have the data. It just didn't exist to start answering these research questions. So we started a sort of a small project to collect it, which in the first couple of weeks was just using Google Sheets to document things, but very quickly grew much bigger. And, you know, where we got to the point where over 3 years, 2020, 2021, and 2022, we were publishing daily data about policies across 25 types of policies, including closures of everything from schools to businesses to borders, public health interventions, vaccine rollouts. And we did this for 185 countries. We also did it across around 200 subnational jurisdictions. I've listed the countries there: Australia, Brazil, Canada, China, India, the UK, and the USA. And you know, it's really great to kind of talk about it in the context of today's discussions, because you know, I think these sorts of data sets are really upstream of a lot of the applications that we'll be talking about today. So before I jump into the stuff about how we did the data set, just a few very quick stylized, give you an idea of what the data was actually used for. You know, one of the key things during the pandemic was that the data was a tool for kind of real-time intelligence for decision makers. So as academics, we got into it because we were interested in research questions, but it was also used by journalists, reporters, governments, really just to get a quick snapshot of what was happening. And so, you know, here these maps show the kind of ratcheting up of stringent policies and closures over 2020. In terms of the research findings that we took from it, so one of the ones was around really policy convergence. So, you know, I think everyone's heard these theories about, you know, was there a difference between democratic and autocratic countries, or did female leaders take a different approach to male leaders? But certainly in the first months of the pandemic, the best predictor of policy response is simply time. And so this chart here, we see almost every country implemented stringent policies at the same point in time, regardless of local conditions. Every row is a country. The blue dots show when their policy settings exceeded a level of 50 on our index, which just means like a pretty broad suite of policies were in place at that blue dot. Now, the black diamond is the first case in every country. The white diamond is the first death in every country. And so you can actually see remarkable policy alignment in mid-March 2020, before most countries had even had their first death attributed to COVID-19. So most of those white dots are after the blue dot. And you see a lot more variation in later months. So the red dots are when the policy settings were eased off below that 50 level. And so at that point, country policy becomes much more shaped by domestic conditions, epidemiological conditions, political conditions. That's kind of what you'd expect. But in the first months, there was a lot of convergence. There was really, all the countries jumped on the global bandwagon, as it was. We also use the data to look at how people comply with policies over extended periods of time. So the short version of the results is that for requirements that are costly or difficult to comply with, like physical distancing that has like a high social and mental cost, compliance starts dropping off almost immediately. And, after 4 months, you're significantly lower compliance. The opposite is true for requirements that have relatively low cost to comply with. And so we would talk about mask wearing in that context, where it certainly doesn't have the social, psychological costs of isolation. For requirements like mask wearing, we see compliance rise over time as that stays in place. These are just a couple of quick research findings. We've published half a dozen papers on it, but we've also been very encouraged because the data has been used in literally thousands of other academic applications and research findings. So that's kind of a quick overview of what the data is, what it's been used for. But the substance of the talk that I'll be going through this morning is really talking about managing and building a data set like this in real time. And certainly throughout the whole 3 years of data collection, we always referred, our catchphrase was, we're building the plane as we fly it, because we were really developing, adapting and fine-tuning our data scheme in real time. And, I think my first point about designing the data system is just that it is very hard to do when you don't actually know what decisions need to be made or what data is needed to inform those decisions. So like when we set out in March 2020, we didn't know what data would be most useful for decision making. We certainly didn't even know that there would be things like vaccine passports, that there would be new variants. We were really starting from a point of relative ignorance about what the pandemic was going to be like. And, I think, speaking candidly, like we definitely made some decisions in March 2020 about the design of our project that locked us into suboptimal path dependency. And we would have made those decisions differently with the benefit of hindsight. And I'll run through a couple of those examples just to give a bit of a sense of the kind of design challenges that we had, and I think that anyone would have when doing a project like this. And so the first one is really about what the overall policy menu is that you're dealing with, how you define the set of things that you want to capture, because you can't capture everything. That becomes an impossibly big task. So you have to pick which are the most value things to capture and include in your data scheme. And then the other thing that you really need to make a decision about, or we certainly did, is how to deal with subnational variation. And you can almost think of like a sort of a fractal pattern where the further you zoom in, there's kind of finer and finer resolution to where decisions are being made. There's countries, but then there's states, and then within states there's counties, and within counties there's cities, and some decisions can be made at any level. And so you've got to figure out how you deal with that. And obviously the number of entities gets exponentially bigger as you zoom in. So on that first point about the kind of set of things that you capture, we certainly found that the common approaches, or the approaches that were notable, the policies that were used, changed all the time. And so we were constantly playing catch up to try to accurately record the most important policies that were being implemented. And to give a bit of insight into how we designed our data system, when we started, we had just 7 indicators, and that didn't even include stay-at-home orders. So when we started in mid-March, countries were not issuing stay-at-home orders. That came about 2 weeks later in late March. And so we had this kind of the first month of the project, which is actually in this chart, those 2 bars, the kind of core development period. We added 4 new indicators. One of those were stay-at-home orders. So we went from 7 indicators to 11. And that was kind of the first month where everything was fluid. But after that, we really did kind of become locked in a bit to our system. We'd invested in building the infrastructure behind it, and it became much more costly to add new indicators. And a good example of that is mask wearing. So in this chart, the blue line shows you how many countries, or the proportion of countries that were doing school closures, and the red line is the proportion of countries with mask wearing mandates. And you can see that during our core project development period, lots of countries were doing school closures. So it was very obvious to us that that should be one of our indicators. On the flip side, during that core development period, very few countries, maybe 15%, were doing mask mandates. And so we actually didn't focus on that as one of our first tranche, our first 11 indicators. A couple of months later, by June, July, as you can see in the chart, a majority of countries were doing mask mandates. It was very obvious to us that we needed to add that, but it took us about 4 months. We didn't actually publish mask data until October because, you know, once we'd kind of locked into our initial set, it was quite costly to go back and historically collect mask data so that we could publish it backwards looking. We had to develop a side team that was to the side of our main team. You know, most of our resources is just keeping everything up to date. So we had to have a side team just working on masks. And this cost got greater and greater as we went on, as we started adding vaccine policies, as we added new policies around, say, economic support or shielding for vulnerable people. And towards the end, if we wanted to add a new indicator, it would have required around 500,000 data points be collected, which is a lot when we're still collecting thousands every day. So there's definitely at the start of the pandemic, you don't know what policies are going to be important, but the decisions that you make about what policies are important will have a huge influence, and for us had a huge influence on what we were recording as we went forward. The other point I mentioned was the variation within countries. So the way our data set is designed for each of our kind of 25 policy indicators, we really want to try to report things as a single number so that it's as simple as possible for users. So you can say, you know, how strict is the border closure? Is it a 0, 1, 2, 3, or 4? As simple as that. But that doesn't necessarily help you account for subnational variation, where maybe there's a stay-at-home order just in one city. Now, when we started the project, that wasn't very common. Most policies that we saw governments implementing in March and April 2020, most policies applied across the whole country. So the decision that we made was that we'll just have a binary flag that sits next to each indicator, and most of the time that binary variable is going to have the value of 1, which says this policy applies across the whole country. And then by exception, we'll change that to be a 0, just to signal that this policy is geographically targeted. So maybe it's half of the states, but not the whole country. But you can see in this chart, which I'll talk through, how that really obscures a whole heap of useful information. So on this chart, it shows for the US, where we do have state level data, it shows how many states have school closures, which is the blue line, or business closures, which is the green, and stay-at-home orders is the brown reddish line. And so you can see there, certainly during say April, there was a peak in all of them. And so, you know, it's quite useful for us to say aggregating at the national level, where for 180 countries, all we had was one national number. So aggregating at the national level, we will be saying, yes, there is a stay-at-home order somewhere in the country, geographically targeted somewhere in the country during April. That's quite useful. But we report the exact same thing in August, where you can see it drops down to only being about 10% of states. So the limitation with our system is that we really report the same value at the national USA level. And so, you know, in USA, yes, we've got the state data, but for other countries, we don't. We report the same value regardless of whether that stay-at-home order is applying to 75% of states in April or 10% of states in July. And so for us, certainly at the time, this was the right balance between having a coding scheme that was feasible for us to collect the data for versus having one that as accurately as possible represented the state of the world. And I think, you know, that was, as I said, most governments were using these general policies most of the time. But as we've seen, as the pandemic went on, governments got much more interested in very targeted policies. And I don't quite know how we would deal with that otherwise, but just to say that we had locked ourselves into this path dependency with this coding scheme, that, you know, by about 6 months in, we probably realized that it wasn't the best way of reflecting subnational variation. And that's why for some of the bigger countries, we did actually just invest the resources to literally collect older data at the next jurisdiction down. And of course, it takes 50 times the resources to collect state level data as it does to collect national level data. So that's the other limitation I'd say we hit when designing our data set. But I'll talk a bit now about collecting the data, because this for us was, you know, the biggest part of the work. And we did it through a team, or perhaps an army of volunteers. The first point on this slide, and really the first point to make, is that because we were recording real-time daily data, it's a massive data set to be manually entered into a system. It requires just a massive amount of resources. And stepping back and looking at the global data system that Risto mentioned, it was really mostly universities and NGOs that did this work. So, you know, not just us. I've also mentioned there Johns Hopkins and Our World in Data. And, you know, while some of this was machine readable because it was sort of country statistical reporting on, say, vaccine rates, that's still a lot of work to collate it all together. And not to sort of make it sound like we had it harder than anyone else, but there is no common statistical reporting measure for policies. There's no common statistic for how stringent your public transport closure is. So our volunteers, and we had hundreds of them at any point in time, our volunteers had to manually search for and then code in policy data every single day. So when thinking about, you know, how we kind of generalize this approach to data collection to address other global issues, something I get asked about semi-regularly is, you know, could we do this for X? I'm always a little bit wary of being too optimistic about our success and its generalizability. I think we set up this project at a very special moment in time where a lot of people had time to contribute to a project and were highly motivated to contribute to the global solution to COVID. It was very hard to motivate that many volunteers beyond 2020. So for, I'd say, the last 2/3 of the project, we put most of our effort into working with the volunteers, making it a fun and enjoyable project for them, and indeed dealing with churn of volunteers. And so I think for global issues where people are thinking about, say, standing up a data collection effort like this that runs indefinitely, really the volunteer model or the data collection model is probably the bigger challenge, even more so than the stuff I was talking about before about like data structure and design. I do think there's probably some clear things that you could do. For instance, going to less frequent data collection. If data was collected every month, that's 30 times fewer data points. If data was collected every 6 months or just twice a year, then that's reducing by several hundred times the amount of data that needs to be collected. And certainly for administrative data or statistical data, things like vaccine rates, we shouldn't need to rely on manual work by universities or by kind of public good projects. That's the kind of thing where data standards and taxonomies and systems should be able to automate a lot of that. And I'll come to that briefly at the very end. The last thing I'll say about how we did it is just to talk about how we published and the infrastructure we used for getting the data out there once we had collected it. So during COVID, I think most people on this call are probably familiar with this organic ecosystem that emerged on GitHub for storing data, and then on Our World in Data for visualizing data. You know, I think there were these two great tools for storing the data sets, and then Our World in Data kind of took all those stored data sets and published them in interactive ways, which was awesome. But I would say that GitHub has technical limitations as a data store, and I can certainly imagine something that would work better. You know, just to run through it, GitHub's really optimized for storing source code, not databases. So for instance, it has file size limits of 100 megabytes, which some of our data sets are greater than that, so we have to split them up. When you download a repository, you get the whole history, which, you know, for source code is useful because you want to see the changes and the diff files. But for us, if someone wants to download our repository, there's maybe a few hundred megabytes of useful files, and then there are hundreds of, or over 100 gigabytes, literally 100 gigabytes of historical past commits and old data. So it's not super user friendly if someone wants to download the repository. And there's like no standard APIs for calling data. Everyone's data was formatted slightly differently. It's just quite a different experience to, say, a data warehouse that's built for this purpose. So you can think of the global data sets managed by like the World Bank or the OECD, where everything just fits together. And, you know, the stuff that Risto was demoing, really the team working on the X Prize basically had to build this platform for themselves because it didn't exist, because the data was just unstructured CSVs, or sorry, not commonly structured CSVs out in the wild. So look, to wrap up, you know, at the Blavatnik School, we've been thinking a bit about what we might want in place next time a global pandemic rolls around. And we've specifically been thinking about the data system. So I think there's a lot of people around the world thinking about pandemic preparedness. Our part in that is thinking about the data systems that support pandemic response. And as I kind of touched on before, certainly we can look around and see what was missing this time. So there were things like a lack of global governance of data, a lack of common APIs and standards and taxonomies that helped things fit together, a lack of platforms and digital infrastructure for publishing, storing and collating the data. And so some of our recent work, and I've got a link there to our most recent working paper, was on this topic, sort of starting to sketch out a possible forward agenda, starting to sketch out our thoughts on what was missing and what could be built so that the world is sort of better prepared with more fit for purpose data systems for the next global pandemic. But that's kind of my quick run through of what we did and how we did it. As I said, real pleasure to be joining you from Melbourne. I'll be sticking around for the rest of this morning's discussions, but I won't be around for the whole day because it is starting to get late. But Risto, I'll pass back to you. Thanks again.
Yeah, thanks a lot, Toby. We have some time for questions. If you want to ask a question, make sure to unmute your microphone. I can start. Just following up on what you just said, it would make sense for the world to learn from this experience and actually have governments and organizations, hospitals, to start actually some kind of a program to collect the data and make it available in some kind of a form that others can consume, and maybe even data consortia to start to collect it already, even when there is no pandemic. What do you think are the chances of that? I mean, we had a couple of workshops on this topic already related to the pandemic, and it was surprising to find out that even hospitals won't give out their data. I mean, during the pandemic, that was impossible to get. So you have to just basically scramble to get the data together. And you guys did a wonderful job at that when it was actually happening. But there's a clear lesson. And what do you think are the chances? What would it take to actually build such an infrastructure that the data would be routinely collected and would be available when we need it?
Yeah, I think, certainly my view on this is that it's more of a political problem than a technical problem, at least certainly at the global level. So I know that in COVID data reporting and in other issues related to World Health, the WHO has kind of faced resistance with automated statistical reporting. Countries governments, states want to control that flow of information and not have independent automated data systems that automatically generate that. So I think my view is to the question, how possible is it or likely is it? I think the barrier would be having that political will from states to establish a system. I think, technically, if the governments of the world said, we want it such that anytime a hospital reports a death from disease X, that automatically updates a database held by WHO or someone else that has the overall country statistics. If the governments decided that was something that they wanted, I think technically it would be possible. Certainly there's issues in some places in the world where there's not sort of e-health record keeping systems already, but for COVID countries still, like local health authorities still found a way to develop those statistics. So yeah, I guess back to my initial reflection, technologically, I imagine it's not the main barrier. It's building that political will for an automated system where the information does not pass through member states on its way to WHO.
Yeah, and of course, once you actually have demonstrated that it's possible to put that kind of a data set together, it's a lot easier to do now. Politicians can't claim that it's impossible because it's already been done once. So I think that's really important, but who knows? People and world seems to have a kind of a very quick amnesia about what happens. So we have to keep pressing on that. All right, other questions to Toby at this point. Well, we'll have time for discussion also after at the end of the session. Maybe at this point, I can, well, let's thank Toby one more time. Very, very substantial project and a great presentation, great start for the workshop. Thank you. And I'll continue with what I had to say, using Toby's data, what we did and what XPRIZE did. Let's see if this works now. If it doesn't, we have to just do something else entirely different. Okay. Let's see. Here's the demo. And it came up. That's the start. I had to reboot, the old good old-fashioned reboot. So yeah, I was in the middle of giving a demo of the system that we built on the data. In that URL that you saw, it's available in the web. I've selected a country, in this case, India. I mean, there's hundreds of them, 280, I think. And I picked the date, March 1st, 2021. And this is the past number of cases. This is what actually happened. Since we actually went to the past, we know what the right answer was. This is what our AI would have predicted if the AI MPI, sorry, this is the AI MPIs. So at this point, this is the number of cases and the different MPIs. And this is now March 1st. What the AI suggests is close the schools, close the workplaces, public transport, stay at home, really drastic suggestions, basically close down the country. But if you do it, the predicted number of cases is actually pretty low. Now, there's a lot of uncertainty. This is a mechanism we developed in order to estimate what the uncertainty is. And it often is growing uncertainty as you go further into the future. But by and large, this suggestion, we believe, would have held. Now, these were the actual MPIs, and you can see that India was slow, starting with schools and workplaces and many other places. They kept them open, and that's how the peak happened. And when they were at the peak, that's when they implemented a full shutdown here, a little later, and the cases eventually came down. But the prediction here, the lesson to be learned is that it is possible to avoid this if you have a system that predicts far enough in advance and a system that figures out how to actually cope with it. Now, but this is pretty drastic, the school closing and workplace closing. That's hard to do. Now, we have in the system, we have this facility to try out different alternatives. Starting, for instance, the AI's recommendation, the decision maker might want to go and say, that's too harsh. I need to keep the schools open. I need to keep the workplaces open. But I can, cancel public events and restrictions on gathering. I have to keep the transport open. People won't stay at home, and they have to move. But I can close the borders. I have testing, and I can require masks. Let's see if that works. Can I actually avoid the peak that way? And we can try, but as far as I remember, it turns out that's not good enough. There is now, we asked the predictor what would happen, and yes, the peak would have been even worse, is the prediction, if you try to do something like that. So in a case like this, really closing the schools and workplaces is the only way to avoid, and other very stay-at-home requirements, the way to avoid that peak. That's the AI suggestion. So that's a very quick demo of the interactive system that allows the decision maker to see the alternatives, evaluate alternatives, and then make decisions based on that. All right, let me wrap up by talking about the X prize. Well, okay, first, one more thing. It's also really important that you understand where those predictions and prescriptions are coming from. Now, we have a data-based prediction and prescription system, and they are neural networks, and they are opaque. But we also developed an alternative for that, and which consists of evolving rules. And you can actually read these rules. These are relatively complex. You can run some cleanup mechanisms and translate those into natural language, and you can read where those decisions are coming from. So this different kind of AI, not the kind of generative AI, it's explainable and it's interpretable. You don't quite get the same accuracy. There's a little cost to be paid for explainability, but you can actually see where the decisions are coming from. And that, of course, helps the decision maker to understand why the AI is making recommendations it's making. Okay, then the X prize. So this was the fastest X prize ever. X prize started maybe 20 years ago with this private space flight challenge, and they've had about 20 challenges since then, mapping the ocean floor, feeding the next billion people, several X prize challenges during the pandemic. This was one where we really were in a hurry at the end of 2020 because we thought the pandemic would be over in a couple of months. Well, we wish, but we're actually really happy it wasn't, right? Because we had a good chance to demonstrate AI. We could have traded it actually if we had. But anyway, we had run it very fast, and it was quite a tour de force. X Prize personally was wonderful to helping us build it out. So Amir already alluded to that. The first phase included people developing predictors. There were about 100 teams that entered from around the world. And we winnowed it down to 50 finalists who then went on to phase 2 to develop prescriptors, another set of models. And they could use any technique they wanted. It doesn't have to be evolution or neural networks even. And people used various kinds of techniques, including standard epidemiological models and even hand design rules and so on. And it did have an effect in some cases of informing government policy, which was really nice to see that. But it's a story of its own. How do you actually do it? We learned a lot about it. And basically, you have to be there with the government from the beginning in order to have an empathetic ear there. Now, one important thing I wanted to point out about the X Prize is not just there were winners and there was a lot of publicity towards science and dealing with COVID-19 with science. That was the main point. But we also found that there were some interesting research questions, including leveraging human insights. So now we have 50 teams developing prescriptors. They developed 169 different prescriptors. So we can think of that as a human creative enterprise. The whole community comes together, makes suggestions. This and this and this and this is how you should deal with the pandemic. We can use that as an initial population for evolution to come up with better solutions. And if you do that, you can see that there's quite a bit of improvement. These blue dots are the human suggestions or human design prescriptors. When we run evolution on top of that, we'll push the Pareto front boundary way to the left and down. Much better solutions. And also, this is much better than running evolution from scratch, starting from pandemic policies that are just randomly set and trying to find better ones. So this demonstrates that we can use AI to bring together the whole community of human expertise and insight and come up with something even better than the humans can and better than AI alone can. What's also really important and interesting is that if you look at how good those initial solutions are and how much of their DNA is in the final Pareto front, you find that, yeah, mostly if you have good solutions, their DNA is there, but there are also bad solutions that are overrepresented. Good ideas that are embedded in otherwise bad solutions. So evolution can figure out what's valuable about an idea, even if it's not fully baked yet, and make it happen. So this, I think, is a great suggestion. And in the future, AI can be used to help human insights to come out and combine them and come up with some better solutions. Okay, so the story continues. The original demo was to draw attention to science, and X Prize amplified it tremendously. We got 1.2 billion views in the media, supposedly. Don't quite know how they count it. And then we have a couple of continuations in the pandemic domain with the global partnership of AI, focusing on multiple models. And there's an NSF side funded project on communication, because that turned out to be a real challenge. And this project Resilience is also, in a sense, a continuation of X Prize and the demo, but now broadening it to other domains. And that's part of the workshop. One of the breakouts is on use cases. What should we do? Is it forest fires? Is it climate change? Is it food shortages? Where can we use this kind of an approach of building models to predict and building models to prescribe, maybe bringing in human expertise as well? So that's our charge for today, is to outline the possibilities and potential next actions. So that was the conclusion of the introduction about data-driven approaches, why it's worthwhile, how it can be flexible and adaptable, and how we can build technology on top of that to make it useful for decision makers. I showed a bunch of examples of that in the slides, and the future expansion of where we're going with it. But I think the technology, by and large, is ready. Data is often the bottleneck. And that's what we'll hear about next. The data considerations, another keynote here by Yu Myung Lee from the Liverpool John Morse University from computer science. And go ahead, maybe you can connect to the Zoom and turn on your mic and
okay.
Go ahead.
Yeah, thank you so much. So I needed to share my screen. So then
Yeah, I have to stop.
yeah, stop. So let me share my screen. So I believe now you can see my screen. Yeah. So hello everyone. So my name is Gyu Myung Lee from Liverpool John Morse University. So my talk is more relevant for various kind of general considerations related to data. So today we have talked about so many issues for data.
Can you hear in the back?
Okay, so
Almost, maybe a little louder.
okay,
Yeah.
so in this regard, from the data and AI context, I would like to emphasize what are important considerations. So there is some important principles later. So based on that kind of principles, I also would like to emphasize various kind of technical aspect. Later part are related to two important points. One is data model, and the other one is the necessity of standardization. So firstly, start here. So we know very well the importance of data. So rather than just the simple data, we really need certain actionable knowledge for creating value. So value is a very, very important things. So how we characterize various kind of important features from the raw data, so then eventually we can come up with some particular intelligence. So in order to do that, there are lots of available tools, solutions, including cloud and various kind of computing resources, etc. And then most of the things we always talking about how we utilize AI for supporting this kind of intelligence. But of course, there are lots of risk environment and various kind of threat. So definitely we need to think about how we successfully resolve this kind of points. Starting point was, I believe, IoT. So without having IoT technologies, like so many number of sensors, so we cannot imagine this kind of current situations for collecting lots of data. So based on that kind of key environments, so we are talking about data, rather than just the small data, big data, and then we are talking about how we best utilize this data for various kind of intelligence applications with the AI techniques. Currently, this is the diagram from EU 5G PPP. So as you can see in the middle here, there are lots of components, various kind of technical components like clouds, networks, IoT, big data, etc. So rather than independently considering this kind of solutions, we need to think about how we will harmonize these kind of solutions in order to best utilize AI solutions with so many number of models and algorithms. Eventually, we also need to support, here mentioned cybersecurity, but I would like to emphasize the need of trustworthiness. So how we successfully support these kind of things, then we eventually come up these kind of key ideas. So our starting point was AI and the data commons. So from the AI data commons concept, the key idea was PCI. P stand for participation, C stand for collaboration, and I stand for incentives. So instead of just collecting so many number of data and recruiting many contributors, more importantly, we need to successfully collaborate. So we know lots of tools. However, if we really wanted to promote this kind of collaborations, we also need to think about how we support various kind of incentives. So that kind of things are very, very important things. So then a platform should be very successfully support this kind of key demand. So regarding this one, we started to consider so many different elements from contributors and the various kind of different models for prediction and the prescriptions. And ultimately, we would like to support various kind of key decision makings. Actually, I would like to also emphasize this kind of global initiatives. So from the UN, they really intend to consider to support lots of technical solutions, including standard. So we really need a certain API. We also really need certain alliance, how we facilitate this kind of key demand. So based on this one, for example, in the here, public good standards. So there are lots of different demand and different purposes, but eventually I really wanted to emphasize one important directions regarding openness. So open, that is kind of important keyword. Among so many number of important keywords, open is really, really important to successfully support this kind of initiatives. So in this regard, globally, there are lots of ongoing activities to support open. In the later, I also would like to mention some important bottlenecks, but now here, I believe today's talk, this slide summarize everything. So when we talk about data, I believe 12 principles here are very, very essential element for considerations. Instead of just system-wise or certain device levels, currently we are talking about ecosystem. So lots of global and large-scale systems. So this is a kind of ecosystems of systems. So many number of things we need to consider. And then so far, we have concentrated on connectivity issues, how we connect them, but more importantly, data usage is more important considerations, how we best utilize data. So data usage is really, really important point for engineering purposes. And then instead of just one specific element, such as collection, processing, analytics, etc. So we need to think about entire life cycle. So data life cycle is also important element. From number 4, this is really, really important considerations globally in terms of standardizations. How we commonly understand the meaning of data. So that's the really important demand of a common language, ontologies, etc. So we really need common understanding of collected data and then common data models. That's the very important tools to successfully interchange various kind of different data among different stakeholders. And then there's another tools, how we add various kind of meanings there. This is a kind of a curation. So we can put various kind of important information there. And then, as I already mentioned, trust is really, really important in the context of data sharing. So we really need to share data. We definitely need to share. Without sharing, there's no values. There's no big impact. But there are lots of controversial issues between public data and the private data. So that's the really, really important. But frankly speaking, it's not really possible to consider only technical points. There are lots of implications from regulatory point of views. So that kind of things should be well considered. That's the governance in number 8. And then we also need to support how we quite distributed and very, very individual users are contributing. This is not a centralized manner. This is really decentralized solutions, like currently blockchains, etc. There are many tools to support this kind of points. And then many individual technical elements are integrated. Then there are lots of tools like data fabrics, and then how we extend this kind of data spaces gradually. And then, as I already mentioned, the decentralization, this is also tightly associated to user centricity. So user demand, user-centric approach are very, very important point. Even though certain global companies, giant IT companies, they have certain particular ideas, but more importantly, individual users wanted to get certain particular ownerships and a particular right for controlling their data. So how we support these kind of things? So that's the whole point for data considerations. I do not want to explain everything, but each items, there are lots of points. So if you need the detailed information, then please refer to my slide. So I would like to open this slide after this talk. So then let me consider the next point. So how we successfully support this kind of trends in order to support data and AI commons globally. So I believe currently there are lots of ongoing activities, as you here mentioned, data-centric ecosystems. Mostly, I would like to show some particular approach from EU here, such as Gaia X. So they really wanted to build up their own cloud systems for facilitating to utilize large amount of data. So that kind of things are with very important initiatives to support so many things. Another important point in the here, eventually, instead of individually considering this kind of the importance of data, we probably need certain space here, targeting data. So we need a platform, we need marketplace, we also need lots of individual users demand. So how we support this kind of whole things. So in the beginning, I also mentioned the value, certain particular valutizations or monetization of data. So then marketplace is also very important things. Some case, definitely we can open, but some case, if we create certain particular values, so then we really need to give incentives through the transactions of data. So there are lots of things to consider in the data space. Then eventually, EU came up this kind of diagrams to support important building blocks. Interoperability is a very, very important traditional aspect. So another point, I really wanted to emphasize 3 additional things. Trust is really important. Data value instead of just the original data. So we should always think about valutization. And then without having proper governance, it's really not possible to realize these kind of situations. So in this regard, apart from various kind of technical elements, we also need to think about so many number of governing and non-technical aspects together. So based on this kind of things, let me now explain one important element. So how we successfully this kind of build up this kind of a certain particular environment. So as I already mentioned in the beginning, we have a lot of tools. This kind of technical element need to be well integrated. But more importantly, one of the important element was common language, common understanding, various kind of common models, etc. We know very well there are lots of different domains. However, as you can see in here, basically depending on different purposes, we can think about lots of different models. Originally, from the communication perspectives, there are lots of models to understand underlying environments. So what kind of devices, what kind of communication protocols, etc. But now we are talking about data. More logically, we need to know certain relational aspects and the meaning of the data, and that these kind of data's meanings are gradually changing over the time for trainings, etc. So how we continuously trace this kind of different changes, etc. So without having concrete rules as a model here, it's really not possible. So in this regard, there are lots of different level of data abstraction models. but there are also lots of different usages, how we consider this kind of different models, and then various kind of different processes we definitely need to consider, and then many different perspectives, some hierarchical point of view, relational point of view, some case certain particular entity oriented, some case certain particular object, various kind of different dimensions. So that kind of things should be well covered. I would like to skip these kind of examples, but then what is the next step? So I have emphasized various kind of important element. One of the important tools or certain particular element will be data model. So data model is really important work items for standardization. You can generate your own data model, but you can just simply utilize this kind of models internally. But if we really wanted to consider global interoperability aspects, definitely this kind of models should be well standardized. So in this regard, so many activities, like here, we wanted to consider data, we wanted to share data, we wanted to reuse data, then there are lots of things to be considered. So I have just added some activities regarding certain document here. So I think it's not really a good time to introduce all the details, but I just wanted to show what kind of a document have been currently considered. So for example, we can consider certain particular target environment like smart cities, etc. So then targeting city environment, we could develop certain models, etc. So if we consider various kind of devices or providers or certain particular operators, so we can think about how we understand this kind of different environments. So that kind of things need to be characterized. So then instead of just a simple interoperability aspect, in a semantic level, understanding of the meanings, that kind of a different level of interoperability is really important. For example, in the here, certain particular relational aspect between physical things and the virtual things, etc. And then we can put lots of information inside the software there. So that kind of manner, we have also developed lots of documents such as metadata. So metadata is really also important tools to giving various kind of important informations to individual data. Some different kinds of metadata also proposed, and then there's kind of different things. As I already mentioned in here, for example, interoperability point of view, instead of a very conventional communication level interoperability, we need to think about different level of interoperability at the semantic level and at the syntactic levels, etc. So then eventually we can understand more correctly. So that kind of things is also one of the important directions, how we firstly well define various kind of data models, and then how we successfully work together with the multiple data models. This is an interoperability aspect. So many different target environment can be considered. Another important thing is blockchain. So we know very well currently the importance of a blockchain. So one of the reasons to use blockchain is to support trustworthy environment. So we really wanted to consider very secure and reliable environment. And then their kind of whole important transactions need to be well recorded. So that's the reason why we consider blockchain. So currently, there are lots of different points regarding different types of resources. Instead of, we are talking about just the data, but if we look at so many different elements inside the data, some case data can be interpreted as a certain particular data assets, some currencies, etc. So many different types of data should be considered. Then lots of different ways to treat this kind of data here. So in this regard, there were some strong demands to use blockchain in the context of data sharing, more securely and transparently share lots of data. And then currently, there are some activities to support various kind of data models, but instead of just closed or some particular the regional aspect, there are some demand regarding two aspects. One is open approach. So many volunteers are contributing to develop their data models and then continuously accumulate and then add on various kind of new features. And another thing is, even in the data model, like here, we can always think about smart data model. So data model itself can be evolved to correctly identify and adding various kind of new features autonomously. So that kind of things are always very, very important things. So many colleagues, many stakeholders are contributing to develop this kind of data models, such as here, open digital architecture. So data is one of the key elements. Currently, most of our stakeholders are very commonly considering how to support these kind of data models. This is the one specific environment point regarding smart cities. Recently, IEEE and the ITU collaboratively considered to support smart cities with several tools like a common language, as I already mentioned, correlation with ontology, better understanding with some AI-related stuff like digital twin. So we can add various kind of new solutions there, some intelligence. So that kind of manner, lots of things are currently considering. All these kind of ongoing activities are basically based on data. So in this regard, now I would like to wrap up my talk here. If we summarize this kind of whole demand as various kind of technical considerations, etc., for data aspect, I believe in the future, we should well consider three elements: data, networks, and the AI. This is a DNA. So more importantly, how we well link between data and the AI. So there are lots of useful tools, blockchain, networks, and computing resources, etc. But without having trustworthiness, it's not possible. So in this regard, we're always thinking about how to successfully support transparency, data protection, privacy preserving, policy and regulatory issues, and ethics. There are lots of things to do. So that kind of things should be very well supported. From the standardization viewpoint, we have lots of elementary solutions. So we should well consider to collaborate to successfully build up our own data ecosystem, basically for trustworthy and decentralized approaches. Eventually, with the AI, that's the key point of the talk. Thank you.
Yeah. Well, thank you. Yeah, so we really have to move on because we're kind of behind, but maybe time for one question, if there's one from the audience.
I have a question.
Sure.
I'm Mihaela Uliero from SingularityNet, and we're building AI on blockchain. So you said at the end, you mentioned that decentralized data with AI. I think it's for AI. I don't know if with, but the question is, I really appreciated your talk very much. Especially in the context in which, large institutions are not open to decentralization and blockchain. And you mentioned, and there was like technology and challenges. And then decentralization, you said technology decentralization and challenge decentralization. I just want to know, what do you mean at the challenge part?
Yes, so
And how can we overcome that? Because
right.
of course, this is one of our main.
Yeah, actually, there are lots of implications regarding decentralization. So I'm not sure. Probably I can explain later in the break time. But more importantly, if we consider AI, then we can clearly differentiate two different purposes. So, for example, AI for certain infrastructure. So, for example, so many networking stakeholders, they are using AI for autonomously control and managing their resources. But more importantly, we need to also think about certain infrastructures for AI. It means that how we efficiently support so many number of vertical AI applications by using many available network resources and computing resources, etc. So that kind of things are also very important, but totally different perspectives. The decentralization point of view, I really wanted to emphasize the need of our individual users. So we can also definitely think about global companies, etc. But why we need to consider decentralization? Basic demand is that the users certain particular right, ownership issues. So if we always think about user-centric approaches, then definitely it should be moved to the decentralized ways instead of centralized solutions. Then eventually, I really wanted to say that decentralization definitely also need to be well coordinated, distributed way, and centralized way together. Eventually, centralization is also definitely lots of benefits, but how we will balance this kind of different roles and powers over so many different stakeholders, and that kind of things are very, very important things for consideration.
Yeah.
Thank you.
Okay, great. Let's move on. Olivier Francon is going to give the next keynote. It's actually going to be a demo, and we are moving now beyond the pandemic domain to actual first implementation of climate change domain, in the climate change domain of the same kind of approach that we've talked about. So Olivier is the lead architect in Cognizant AI Labs. Great, so go ahead.
Yeah, so as Risto showed previously, we already applied our technologies to making better decisions for COVID-19. And we wanted to use the same kind of framework, but to apply it to another kind of problem. And in that case, we decided to work on climate change and more precisely on land use optimization. So the goal is to provide a tool for decision makers to help them make better decisions about how to use the land. So they want to, how to use the land. By that we mean how can they make better usage of the land to minimize carbon emissions. So we all know that the land can emit carbon CO2, or it can actually capture CO2 as well, depending on how we use it. So the goal is to find the best usage of the land in order to minimize carbon emissions. And we actually looked at existing data. There are many researchers that are working on the area, and the land has been mapped all over the world. And we actually know the different constituents of the land over time. So we have primary forest, primary non-forest, for instance, or secondary forest when the forest was cut and was regrown. Crops, different types of crops, and different kinds of pasture or range. We collaborated with researchers from the Global Carbon Budget that are focusing on looking at where the carbon goes on Earth. So it can be released in the atmosphere, it can be sunk in the oceans, it can be captured by the land. And we collaborated with the researchers that work on the land usage, and they estimated actually for a few hundred years the emissions that were caused by specific changes in the land usage. So that's where the data is coming from. They actually developed a model that's called the Blue model that estimates how much emissions are going to be caused by changes in the land usage. So the application we want to provide to decision makers is something like that. They can select a context. So here we have 1 dot for every 20 square kilometers in the world. We focused on just a few countries because it's a lot of data. Once we select a dot, we can see the actual land usage. In that case, it was in 2021. So we can see that 15% of the land was used by different kinds of crops, mostly C3 crops. So C3 is cereals like wheat. And there was 26% of secondary forest in that case and 55% of pasture. And we would like to know what kind of changes we can make to that land in order to capture more CO2. So we trained prescriptors that can give us some suggestions of how we can change the land. And in that case, for instance, the recommendation is to increase the amount of forests and reduce the amount of pasture, for instance. And once we have this new usage of the land, we also train predictors that can tell us how much emissions we are going to cause or how much carbon we are going to capture. So in that case, we are going to capture 0.4 tons of carbon per hectare per year by changing the land by 13%. So it's quite a big change, but it's also quite significant amount of CO2 that we can capture. Just to give you some examples, that's equivalent to mitigating the emissions of about 4,500 people in this example. But of course, changing the land is costly and it's not easy to do. So we have a conflicting objective here. We can't plant forests everywhere. And we can't drastically change the land from one year to another. So we have two conflicting objectives: capture carbon and minimize the amount of land use change. So that's why we actually train a population of prescriptors, and we can sort them on a paddle front, where we are looking for the best trade-offs between the amount of changes and the amount of carbon that we can capture. So on the bottom axis here, we have the changes in percentage, and on the y-axis, we have the amount of carbon that we can capture thanks to these changes. So we can see that the more changes we make, the more carbon we can capture, but obviously the cost is going to be higher. But if we are ready to make more drastic changes, we can get some different prescriptions. In that case, we did not constrain, for instance, the amount of land that is used by cities. Cities themselves don't emit carbon. It's actually the things that are on the cities that emit carbon. So the land itself, when it's transformed into urban area, is not emitting carbon. But what we can do for decision makers is to actually let them modify the suggestions. So they can say, I don't want to increase the land that is used by cities, for instance. I want to constrain it. And maybe I need, I actually still need to produce food. So I need to keep my, I actually maybe need to increase the amount of the surface of the land that is used to produce food. And we can recalculate the distribution of the land that way, and we can make new predictions. So now I'm only changing 10% of the land, for instance, and but the the carbon capture is not as good as before. It's only 0.09 tons of carbon per hectare per year now. So all these tools are for decision makers. So we need to be able to visualize them in appealing ways. They need to really understand the different trade-offs that they are making and the change to the land that they are making. And on the prediction side, we rely on models that we have trained on previous data. So the idea here is to be able to use different contributions, different models from researchers in order to get more accurate predictions. And of course, we are not limited to just one country. Brazil has a drastically different usage of the land. And for instance, there's a lot of primary forests. So this is typically something we don't recommend changing because we can't regrow primary forests, and we know that they capture a lot of CO2. So we might need to train different prescriptors and different predictors for different countries. We know that the data is very different, for instance, for Brazil than from the UK. And that's why we need collaborators to actually help us train different models. We can also ensemble the models to try to get the best predictions from all of them. And once we have good predictions, we can train prescriptors that are going to try changing the land usage in order to optimize the two objectives we are, which are capturing more CO2 from the atmosphere, but at the same time minimizing the cost, so minimizing the changes to the land. So that's in a nutshell the kind of different usage we can make of this kind of architecture where we have data, predictions, and prescriptions.
Yeah, great. Yeah, go ahead.
Sorry. Very, very interesting. Do you take in account like the level of the sea, the rise of the sea level, for example, and the growth of the population, or like how the climate change will impact the movement? I mean, I guess you have a limitation in your model, but
Right. So we are collaborating with researchers from the Global Carbon Budget, which is part of the IPCC report. And the Global Carbon Budget is trying to estimate where the carbon is going. So in this case, we focus just on the land usage, not on the ocean sinks, for instance, and not on emissions from gas and aircraft. Yeah, fossil fuel.
okay.
So fossil fuel is managed differently by another team. So here we only looked at the carbon that is captured by the land itself.
Okay, thank you.
For the presentation. I just want, I'm working on a project on poverty mitigation, which is similar. We're doing prediction and prescription and working with different governments at the local and also at the global level. Now we're trying to integrate satellite imaging too. So basically, thank you for your presentation. I just wanted to ask you if we can talk maybe afterwards to see if we can find synergies, because I can see we are working in very similar ways, but in different fields, and it would be nice to explore potential collaborations. We're working on agent-based modeling with machine learning. I don't know if you use agent-based modeling at all, but
Not really, but we are familiar with the technology as well, and yeah, it's very promising. Yeah, I think the key is, as we discussed earlier, is really to have the data to work with. So in this example, we actually use data from a model that was created by researchers using different kinds of data. So they already did all the work for us, but as long as data is available, and by data, I mean, we need to know the context in which the decision was made, and we need to observe the results of these decisions. We really need to have these three components: context, actions, and outcomes. Because once we have context and actions, we can predict the outcomes. If we're able to predict the outcomes, we can optimize for the actions.
Yeah, we can talk afterwards because,
Definitely.
thank you.
Yeah, and actually, there's a breakout on use cases. Maybe if you can attend that, we can have a discussion of that potential use case. Yeah.
Hey, so this is partly a question about this demo and partly a question about the framing of this workshop. And sorry, my name is Rafael. I'm from a startup called Digital Gaia, and we work on decision intelligence for complex systems. And so I'm really curious about this framing of what are the decisions, what's the decision maker, and what's the decision context in this case here, because. And I think this demo highlights it really well, because just 2 weeks ago on, I think it was Nature magazine or journal, there was a publication that highlighted the issue that the decision criteria that have led to the, for instance, the upsurge of rewilding and other positive nature positive practices in Europe has actually can be you can attribute to that the increase in deforestation in many places that are biodiversity hotspots in less developed countries. So basically many, not all, but many of these policies that are locally optimal for things like carbon mitigation and, you know, improve the quality of the soil and, you know, very, very positive local outcomes. But if you look at the global outcomes for some of those outcomes, it can actually be a tragedy. And so it's actually very hard when you start looking at a Pareto frontier that's not 2D, but it's hundreds of thousands of dimensions. How do you tackle that? And I'm really, I would really love to connect to that, the question of decentralization and user centricity, not just from a perspective of who's the user, but who's the person who's affected by the decision, right? Because if you're considering the effect of the decisions and the outcomes from the perspective of who's local, you're going to get one outcome. If you're trying to propagate these externalities out to the system, maybe the results are completely different.
Yeah, that's a very good point. And actually, the researchers that are working on the global carbon budget clearly identified 3 countries that are the biggest emitters of carbon because of land use change. And it's Brazil, Central Democratic Republic of Congo, and Indonesia. So they account for most of the CO2 release in the atmosphere. But as you mentioned, the decisions are occurring at different levels. Here I'm showing points that roughly reflect 20 square kilometers, but we can be more granular or less granular. Actually, we trained this model on the UK data only. And the pilot form that we display here is the average of the changes we made to the UK land use and the average emissions at the UK level. So the more granular we are, the better, because we can always aggregate the data at higher level. So in this case, we could aggregate, for instance, the dots by province or by nation, like focusing just on Wales, for instance, or we can go at the higher level at the UK level. So like Toby mentioned earlier, a lot of decisions are made at the city level, at the county level, at the state level, etc. So the more granular data we have, the better it is, and the different the results. Indeed, optimizing at a local level is not necessarily as good as optimizing at a global level. I think there was another part to your question.
Well, my question is, how do you deal with the fact that ultimately, like the decisions that are made at a local level with local incentives and local trade-offs have effects that are radically different if you take into account what they induce at somewhere completely around the world, right? So for instance, the UK is a great example. Cattle that is not produced in the UK ends up being raised in Brazil in deforested land in the Amazon, and that goes to the Brazilian carbon budget.
Yeah, that's very hard to capture in the data. So that's very hard to evaluate. But we have multi-objective optimization. In that case, we are displaying just 2 objectives, but we could actually have a third objective, which is, for instance, the impact at the national level or at the international level. Or we could have other objectives, maybe not in the hundreds, but we could easily have half a dozen or a dozen. And in that case, instead of using 2D paddle fronts, we can use parallel plots to actually display all the different trade-offs between the objectives, and then we can choose which one we want to focus on priority. I have some examples. If you're interested, we can dive into that later.
No, technically I understand. I'm just curious who would ever choose to optimize for an objective that they're not incentivized to care about.
Yeah, that's I think a political problem.
Yeah, we'll have to give them alternatives, and then that's a decision makers decision on how to emphasize those trade-offs to take. But that's really good point. We have to have those trade-offs visible first before you can even make the decision.
Exactly. At least we need to measure the impact somehow to actually start the discussion about how to mitigate them.
Okay, maybe we can move on. We have a 4th keynote by Prem Krishnamurthy, Senior AI Machine Learning Architect at Vanguard Groups. And I believe he's joining us from the East Coast. So let's think about that. It was 2:30 there when we started, and now it's 4:30. Is that right, Prem? You have to unmute. We can't hear you.
Yeah, can you hear me?
Yes.
Okay. All right. Can you see?
Okay, so go ahead and get started. We don't see your slides right now.
Okay, let me try
Move
this
them
one.
out of the way. I think they were there. There you go. Now you're moving in to the
Okay.
screen that you're sharing. So we can see your slides, and I think we can see your video too when you start talking. So yeah, go ahead, and sorry for keeping you awake.
Yeah, thanks for the introduction. This is I'm glad I'm part of this workshop, and appreciate being working with you guys last few months. So my perspective is kind of looking through the architecture. There's a lot of work is being done, and a lot of work is still going on. And so this is focus on architecture. Yeah. Focus on architecture, how to step back, right? Is from the machine learning development perspective, as well as the data collection perspective. There's a lot of different challenges, a lot of work is being done. The team kind of thought through like what is the best way enable architecture where we can build on it and continue to bring in additional, like the collaborators, right, are able to come in there, able to contribute easily, because that became a bottleneck, right? A lot of what we do, there's awesome technology there. There's a lot of data collection is there, but we need architecture that enables them to work efficiently so that, the contributors can come in and produce the result more effectively on timely basis, because a lot of work is done. Timing is very crucial for that, right? So that's the architecture is focused on. Some of the, key requirements for those architectures are, we need a secure environment because we want to make sure the contributors are contributing, and not everyone, and the data, there's a lot of conversation on the data too. It's important that data being gathered is in secure place and able to accessible for the right people. And have a environment where data scientists can come and contribute, have a tool, right? So they can build the models, iterate to these models, iterate to the multiple data, and able to produce the results. And you see that they iterate the process pretty much. And also, there's phase 2 of this is, right, able to not only develop the models and deploy the model and see the performance of the model, on monthly or weekly basis, whatever the appropriate processes, right, able to iterate the process. That's the whole the automation of the deployment process of those models and running in this quote unquote production environment, not in the development environment. So it's more stable, it's not touched, so it's not being rigged around, right? And then the data is going to be used. I mean, there's multiple type of data we talked about, right? That just by itself from enterprise level maintaining is not easy. So it has to be very cost efficient to the way the architecture itself. And we need ability to, secure the data, put in a data lake and able to access the data. The insight, right? That's all these insights is getting created through those models. We need able to interact with those with insights. Some of the awesome UI being showed, build that so the collaborators can look at it, or the stakeholders or the decision maker can look at it and make a meaningful decision, right? So it's very important to have those web applications or some kind of insights reporting tools available. The last one is bring your own model, right? Everyone's building the model in their own way, using different technology, or a lot of time just in their own laptops. So once they successfully build it, bring your own model and deploy in this environment and make it available, and maybe take advantage of the tools that the architecture provides. So that's what the requirements is given. It's a lot there. So really our mindset around this is really take the MVP approach. The technology could get expensive. So we want to make sure we leverage building the architecture in MVP approach, make sure it's scalable and used at the right time, so we can able to shut it down or scale up as the demand comes and or goes out, right? So those are the architectural comments we add. In this case, we kind of picked AWS. Again, this requirements hold, and we can, use other provider too to do a similar activity. But in this example, we kind of showing AWS. So the component 1 is really focused on, the service catalog. So service catalog, the video about service catalog is, it gives ability to access the services. Only there are services that you should be accessing, because everyone could be playing a different role part of this ecosystem, whether from data scientists to the engineers, or it could be the decision makers. So everyone don't need all the access. The services are, as you use, you be charged. So it's very important to build architecture to make sure it's being efficiently used. So that's in the service catalog will give you access to the right services that you should be having access to, and come in and do your part and work on it. And the domain studio is, that's the, your IDE pretty much enables you to, whether then to be a notebook or, any models that you have to build. That's pretty much your playground, right? That's where we're going to spend a lot of time building this model, fine-tuning this model, and that studio should have access to the data. Right now, for MVP approach, we're thinking S3 is the data, have access to this data and able to iterate that process locally and prove it out. If it's all good, then then we're talking about deploying this model, right? Then we deploy this model into the more productionized environment. I'll get into that. So productionized environment where there is builds and it trains and validates and registers the model and is available, so that we can monitor the model performance. Part of this process, again, the stuff we talked about is, it's privacy, the governance process, those kind of so critical things. Depends on which part of the country we are in, what are the local rules and regulations we have to follow. So those model monitorings and the data monitorings are plays a huge role there, and those could be easily automated, and part of the process itself can be checked. And then security again, kind of talk about security is going to be a huge part, right? Building this, reusable platform, not only for, current problem that we're dealing with. It enables, what we learned, what's coming up and what's we building, right? It is going to be one playground here, and it has to be secured, and right people should have access to it. Building that VPC network around it. Is crucial and critical. And then we talk about the data portion of it. Data is huge. You can't boil the ocean, right? So we take baby steps. So but this kind of enables you to, as the use cases comes in, we build that lake and probably integrate with other systems as needed basis. But I've been starting with S3 data. Some of the issues mentioned, right? GitHub is not a data source, it's not a database. But there are more cheaper and more efficient way of doing the same thing. So this will enables that. As the use cases grow, there's requirements around it. It's easy to expand those lake as needed. And then the web app and the quick insight is the reporting and the crucial portion. Like all this artwork is going to be visible through the web application or some kind of UI. It's easily portable in AWS environment, and those will give access to the model from whether from the coding perspective or the UIs around that model or multiple models, and compare those models and see how well that performs, etc., and get more information on those models. So it's crucial to have the those web UIs as well as the reporting tool. And bring your own model. The idea is we can build a model anywhere you want, and then just deploy that model. You use this process to just deploy the model, and this platform will take the model and deploy to the production environment. Again, it will be accessed through the UI. I kind of went through faster there, but if you have any questions, I'm happy to answer.
Yeah, all right. Thank you, Prem. So any questions from the audience? Yeah, so I have a question. So this is a conceptual design. How much of this is already, say, designed based on one application like the climate change or land use management in mind, or is this really still general that it can be filled and instantiated in numerous different application domains, use cases?
Yeah, it's a very good question, right? The whole idea was reusability and able to build upon. So definitely the architecture we kind of thinking is not just for one use cases. Obviously, we can start with the MVP for one use cases, but it's really enabling multiple different use cases and building on top of it. It's one instance, and it can scale to thousands of models that are we building or we going to planning to build, right? That's the whole idea of that. Yes.
Yeah. Okay. So in that sense, we've started with the pandemic response model, and now have generalized it to land use, and now with Prem's general approach to the architecture, this is where we open it up, and that's from here we put you to work. So you hopefully been inspired by all these keynotes and presentations, and have thought about what can be done in changing the world using this technology. So next we're going to have breakout. Well, we have a break and then breakouts.
So what we're going to do is we're going to go around, do quick intros. Please 1 or 2 sentences, no more. We will all keep in touch. Amin had a very good question for which I didn't have an answer, but by the end of this workshop, I will make sure that we can all keep in touch. And you know, part of the point is for us to work together and set up you know, some form of collaboration anyway. So we're gonna end then, you know, we're gonna distill. We have, thank you scribes for being here, taking notes and so forth. We're gonna distill this into a report, and we would like to distribute it to you guys anyway. So that's gonna happen. But for this session, let's go around, do a quick round of intros. We will also have to select one of us that's not me to be the person on the panel after lunch that kind of distills and recounts basically what we talked about here at a very high level, and perhaps answers some questions from the larger group. That's going to happen after lunch. So I think we can determine that as we go. But let's start. Andrea, you've introduced yourself already, but why don't you go ahead anyway?
I'm not planning to.
I know.
I'm sorry.
Still.
Okay, I'm Andrea. I work for ITU in the Radio Communication Bureau. And I'm also studying, I'm doing a master in data science. So all these topics are very attractive to me, and was one of the reasons that I volunteered to participate as help.
Thank you.
Thank you. My name is Martin. I work for ITU for the Standardization Bureau. So we facilitate that the members that come to ITU, that they can develop international standards in the field of telecommunication and information and communication technology. My background is computer science and engineering.
Yes.
Hi, my name is Tiane. I wear 2 hats. I work for my own startup, which is in generative AI for education. And I'm also doing consultancies for various United Nations offices on strategic innovation management. My background is both in software engineering, data science, and business.
Hi, I'm Linda. A bit similar to you. I only wear 1 hat, but it's also the head of an organization doing consultancies for international organizations and governments around the world called TFA, and I had the digital innovation team there. And yeah, we have a lot of projects in and around AI, so that's why I'm here. Interested to see what's ongoing. We also have one project with the ITU, I mean, where we do a part and ITU does a part, and we sort of collaborate. And yeah, looking forward.
Hi, my name is Paula, and I'm part of Merkle, and I'm here actually to volunteer and help out as well. And I work within like CRM and Salesforce topics, but also I'm privately interested in AI. I'd like to learn more and go in this direction within Salesforce. Thank you.
Hi all, I'm Nasrin. I'm working for Frank Recruitment Group. We are specialized in IT recruitment, and I am volunteer today to taking notes. And we are specialized, we are particularly interested in AI topics as it's the future of technology. Thank you.
Hi, my name is Amin Hasha. I'm from Lebanon, and I'm President of Lebanese Cyberspace. Also, I am the co-chair of ICANN Middle East Space. And that is, thank you.
Thank you.
Hello, my name is Ahmed. I'm the Chief Technology Officer and Digital Transformation Lead for the UN Economic and Social Commission for Western Asia. And we're focusing on data and AI.
Hi, my name is Sasha. So I just spent the last 6 months or so wrapping up a project with the Center for AI Safety as a technical writer and researcher, developing a comprehensive resource on AI ethics and alignment. My background is in psychology, philosophy, and applied ethics.
Hi, I'm Rafael. I wear one hat. I'm a CTO of a company called Digital Gaia. We work on planetary scale decision intelligence. So we build decentralized AI systems for
helping businesses and organizations coordinate on solving complex challenges. And yeah, I basically kind of stumbled into this workshop, but I've been finding it very interesting and looking forward to learn more about how we can help.
I'm Georgina. I'm a researcher on AI for Good, Berkeley, and the University of Notre Dame. And I'm also the co-chair of the AI for Good special track at the International Joint Conference of Artificial Intelligence.
That's quite difficult to follow, but I'm Paul Averton. I CEO of a company called Fab Data. We do a mix of advisory work and tech and data systems work in education, but in developing countries, so Sierra Leone, Tanzania. We've been working with AI and prediction models for the last few years, trying to apply them to education topics like dropout of children and school planning questions, and increasingly large language models for teacher training. Really nice to be here.
Great. There is cookies, actually. Thank you. Please hand it around and don't tell the other breakout folks. Whoever we choose or volunteers to sit in this panel after lunch, I'm hoping they can get access to the scribe's notes. Would that be possible? Would it be possible to kind of share your notes from this particular session with whoever chooses, just so they can distill it and use it? So that what I want is for us not to worry about taking stuff down right now and just interacting, and we'll have help from the scribes. Okay, so we can do this one of two ways. We can just open it up for people to throw ideas out and we can discuss, or we can go around the table. Which one do you guys prefer to do? Should we go around the table and get people's ideas on use cases, or some people are itching to jump in?
I'd say do that, otherwise people try to dominate
Yes.
conversations.
All right, let's do that. Let's go the other way then. Let's start with you. So what we're going to do is, what this is all about is coming up with use cases for a decisioning system, basically, that has local implications. Therefore, there's incentive for a local data team, data science team, AI team, who's either already working on it or is interested in working on it. And it has local data implications as well. But it has global manifestation. So if we can collect these local decisions for this problem, then we can hopefully broker a system that's useful for even places where they don't have access to that sort of resource. So that's kind of generally the framing. And there could be many, many, many use cases. So the one that you choose as we go around to talk about, actually, I think will also reflect a little bit of the priority and practicality of it. But let's start with you.
Yeah, of course. And just to premise this, we've just started a piece of work with the Bill and Melinda Gates Foundation on scoping this exact question for education. So we're looking at convening people in September time. So if anyone's interested, please reach out later, because it's great to get as many ideas as possible. One of the things we've been thinking about a lot is how do we use these kind of decision-making tools to help education planners and ministries of education in developing countries. So I'm thinking about a middle tier usage. So the district education officers who have to prioritize resources. Some of this is as simple as optimum route allocation for school inspectors. Some of it is for school leaders and how do they allocate class time, and how do you do learning at the right level. So it's adaptive learning for children. So my suggestion, if you will, for a data use case would be education systems, but focusing on this middle level of the people trying to support school leaders.
I see. And then it's primarily around logistic decisioning, or would it be also like curricular decisions? What are the types of decisions that we're talking about here?
So the ideal starting point is what decisions and what do they already do? And a lot of the pain points are on those logistics. So you generally have a small number of support officers and a large number of schools. So how do they get there, and how do you use, prediction models to see when interventions will be needed? Some of this is more advanced resource allocation. So you have very finite resources in a lot of developing countries. You just don't have enough to go around. How do you do that allocation in a data-driven, transparent way is something which is close to the hearts of many decision makers. So the current minister in Sierra Leone, David Senge, has encouraged us to do all this. Building public is his mantra. So how do we use these decision-making platforms? And we already have a basic one to help them.
And what are the outcomes that you're ultimately goals, KPIs that you're solving for here?
So we usually solve for equitable access to resources. And that could mean that it's biased based on need. So you upweight the ones of greatest need. That's generally the one. The long run aim is learning outcomes. So improving children's learning and attendance.
So measuring that and on aggregate, making sure that's actually improving.
Yeah, we use like a pseudo R² value technically to measure the kind of the distribution across local areas.
And you actually see an impact already with your system, do you? I mean, do you see a difference in, for example, resource allocation having an impact on?
Yeah, so we built them a system to do optimum school location analysis. So where'd you build new schools? Because the way it works is the World Bank say to them, we'll give you money for 800 new schools.
Right.
The minister was fed up of being asked, can you build it in my village, basically. So he wanted a data-driven approach. And most optimal location algorithms just solve for population, but that's no good if your policy priority is rural. So we built them a system that can weight policy priorities. And they've been using that for the last couple of years. And I think they built about 1,500 schools and done the teacher deployment based on these algorithms. And our questions now is, how do we make these better and integrate the kind of more advanced data science stuff behind the scenes, while at the same time keep it simple enough so people can understand? And crucially, what I loved about the thing earlier was the simple visualization. If you do this, this happens,
Awesome. Thank you. Very, very interesting use case. Thank you.
I can make comments on your use case if I may.
Can you turn on your?
Yes, sorry. So I wanted to make a general comment on use cases from the experience I've got, which is I think it's important to start by working with NGOs and government officials, because I have seen hundreds of projects, like we all here have very good intentions, right? And we develop projects and we publish articles if we are in academia, but then these projects are difficult to implement. So I think perhaps from my point of view, the path is work very closely with an NGO government official, develop a small project, proof of concept, have results as you have, right? Have an impact, and from there escalate. Because if we start big, it's very difficult then to have a real impact on the population. And then we have all these projects that nobody knows what to do with them, basically. And yeah, I think that's the way to go, basically.
Implementation is the hardest thing, and when you're implementing in rural Sierra Leone, it's
yeah, I'm sure. But part of our thinking here is that the need, I mean, like with COVID, the need was there. Like,
oh yeah,
these folks were already working on these, or education may be very similar. It's just harnessing that into a more like collaborative model. But great point. Thank you for that. Use case wise.
All right, use case wise. Yeah, so one of the projects I'm working on is on poverty. So I work on the different United Nations Sustainable Development Goals. Number one is poverty mitigation. So of course, it's one of the goals. And here we are doing what I was saying before. We have just results for a pilot project with this in the city of Barcelona, working with different NGOs and with the city council. And we have integrated different technologies, agent-based modeling, which is providing different simulations in AI, coding the behavior of the citizens within the city to see what would be the impact if we changed a specific law. So what would be the impact if unemployment benefit was higher? Or nowadays in the city of Barcelona, people get a fine if they sleep in the street. If you have no money to pay a house and you sleep in the street, the police comes and gives you a fine. So what would be the impact on poverty levels if this law was changed, was canceled? So based on this, we are also, and that's the similar thing on the climate change, we are giving guidance to policy officials on to foresee what would be the impact of different changes in the law on poverty mitigation in a non-invasive way.
How often do you measure the poverty levels here as feedback into your system?
Right. So we just had the first results 3 days ago. And we presented them to the government officials. So that's why now we are seeing which ways to continue. One way is now working even more closely with them is have reports every month based on much more data that they will provide to us for the city. So we're like very much working at a local level. And we have other cities kind of in line that they are interested. But also we have a petition to work at a macro international level using satellite images that another project has used to measure poverty, to generate poverty indicators based on the variation. Yes, based on the variation of economic development in certain areas, and also mobile data, they generate poverty indexes using machine learning.
Like how many lights come up, at
Exactly.
night gives you an indication.
Exactly.
Yeah.
And what the problem is that, and that's why I was mentioning before, they have all this, which gives you a diagnostic, but they say, okay, we don't know what to exactly. So then we would come in and say, based on this, let's generate changes in the policy. Sorry if it was a bit long.
No, that was great. I think I just to try to distill it, we're trying to reduce poverty, obviously, but there's a cost. So we want to reduce costs as well, I'm assuming. Right. And the actions we're taking are at a policy level. It seems like very quantifiable actions, such as, for example, what should the fine be or not? How much? Are there other, like, there was something else you mentioned as well as far as policy was concerned?
Yeah, now the first very small trial case, we did it with only 6 laws.
6 laws.
One of them is if you don't have money to pay a fine, then this fine is changed with imprisonment. Oh my God. Which is also very discriminative for poor people, right?
Right.
And so
sounds like some of those policies should just straight out be abolished.
But that's why it was very useful for us to work with NGOs, because they were the ones who identify like the worst possible policies. And that's why we did the simulations with these ones.
Very interesting. Well, thank you very much. Very interesting use case. We'll move to you.
Hi.
Yes.
Sorry.
There we go. Yeah, so similar to you, I also have a general comment about use cases. And that is that in our practice, we often see that the way that verticals are defined is often a hindrance to actually making sense of what needs to be considered. So just to jump into one specifics of what we do, what we focused the most on so far is regenerative agriculture and agroforestry. So our first end-to-end MVP that we also just finished last month is applied predictive models and causal AI to validate and to some extent make recommendations for assisted natural regeneration in Colombia. These are smallholder farmers that are converting former degraded cattle pastures and coca leaf plantations into food forests. So this already kind of highlights that although the thing that the go-to-market product there for those farmers, for those farms is tree planting certificates, carbon credits that they try to go to market and sell in the space. But honestly, like how much money are you actually going to make out of smallholder farms, 1 hectare farms? They don't, even if you have, you know, in Colombia, trees grow fast, it's great. It's not enough to pay the bill. So you have to consider, you have to measure and optimize for and monetize also the social benefit that these farmers get from having a source of calories that is not cows, and being able to get side payments for planting trees and so on, right? So let's say the focus use case is agriculture, but to actually make sense of that, you have to look at a system that spans across agriculture, social poverty, the relationships between that region, that local area, that for instance in the watershed, and what happens upstream, what happens downstream. And so yeah, my general comment is just that it's very crucial to kind of make sense of outcomes across. Yeah.
And so if I understood correctly, you want to incentivize these farmers to move away from more carbon polluting practices to less? Is that
we're working with projects that already exist that all have some fashion of having payment schemes or incentive schemes that are paid for via donations or carbon credit sales to incentivize farmers to regenerate their local.
I see. So the incentive bucket is already there. It's how we distribute it, and are policies also a consideration? Like under what kind of?
Yes. Yeah.
Okay.
Exactly. So one example is, do you get the farmers to plant fast-growing typical carbon farming trees like eucalyptus or acacia pine that grow really fast? They have timber value maybe, and they're very cheap seeds, very predictable. But then you get a monoculture, and it sucks up all the water from the waterbed, and it doesn't give anything back to the population in terms of food. Or do you plant a native forest of fruit species, right?
How do you measure that? Like, it sounds like the benefit measures are also pretty complex there.
Well, yeah, absolutely,
because of all the interdependencies that you mentioned.
Exactly, and that's I think why the interesting part of doing this kind of work in a complex system is that it's not a point intervention. It's like it affects the whole cycle of data collection, of testing and experimentation of what works, and of tracking that afterwards and feeding back into how your recommendations actually affect what happens in the ground.
Very interesting. Thank you. Yes. Guess we need to turn that one on.
Nice.
Sorry, I'm keeping mine on.
There we go. Perfect. Yeah, so I guess I'm kind of thinking of this within the context of international relations and conflict, namely predicting the likelihood of conflict as military AI systems, in particular lethal autonomous weapon systems, become more prolific. So kind of, I think the major use case here is not only understanding whether or not conflict will actually emerge as more and more countries adopt these systems within a high stakes military setting, and continue to delegate more and more high level decisions to them in real time as well, but also the nature of conflict and what it would mean for wars, for example, to be fought between nation states that are actually using technology as their primary means of defense or attack, and how that would actually shape law and international policy. So that's kind of my general interest here. I wish I could have formulated the idea a bit more deeply.
Yeah, so what I'm looking for, and it sounds like a fascinating use case, but I'm looking for how we could actually reframe it as a decision use case, because what you're describing is more of a, let's predict what's going to happen given what we know.
Mm-hmm.
And but I mean, we do have usually some agency. And so whether we can actually capture the agency that we have, for example, what can be done as far as international law or local law is concerned to mitigate and prevent some of these conflicts, for example. So the outcome would be reduction of conflicts, I guess. I don't know what other outcomes would be there, but
I think
yeah.
one thing that I think about a lot within this context is the idea of human enfeeblement. So as we continue to delegate these kinds of high level, or I should say complex military decisions to autonomous systems, we can find ourselves at a point where we actually rely on them too much, and perhaps to an extent where even if they're giving us the right kinds of classifications and predictions, they may not always consider all of the relevant information at play. So in terms of kind of understanding how to structure better decisions, that might be something that we consider in that process.
I see. Well, okay. Wow. That's a use case that I would like to totally avoid talking about right now, which is the decision making on behalf of those autonomous systems. Let's all decide right here and right now that we're never going to help anyone with autonomous military decision making. But yeah. But what I would like to look at is the counter to that, which is how can we avoid that, reduce it? How can we reduce conflict as a whole? I mean, a while back, someone who is an expert in North Korea contacted me, and she's like, yeah, we've had all these negotiations and we do things and, you know, military maneuvers, blah, blah, blah. And, you know, we want to do this in a way that is actually effective. I'm like, great, wonderful. You know, this is like a step in the right direction. However, there's only been like, I don't know, 12 instances of some sort of breakthrough with North Korea over the entire history of this. And so we don't have enough data.
Yeah.
But then maybe we have data on other conflicts and other situations, historical data that can be distilled to understand how best to react or act so that we can contain or reduce those sorts of things. I'm much more interested, I should say, in that kind of use case.
I think, yeah, we can, I mean, there's a lot of, I think, existing paradigms that we can supplement it with, namely from game theory and bargaining theory that we can look at.
Yeah.
That would help kind of enhance the way that we inform the decisions we make.
That's right. Yes, there's a lot of work there, but I would like to think that data-driven modeling can also contribute. And by the way, I think hopefully we didn't give the impression here that it's all about, you know, just collect the data and build a model on it, because it's not. I mean, as you've also pointed out, oftentimes it's an ensembling of models and agent-based approaches and other approaches that finally give you a decent enough prediction to be able to work
science-based.
Exactly.
Yeah.
Exactly. And even capturing just, you know, common sense. All right. Well, thank you very much. Let's move on. Yes.
I was in a workshop with people from Pentagon. I don't know why I was there, but yeah.
No cookie for you.
And actually I was really freaking out because there were arguments kind of these kind of autonomous weapons, we need to have them and we need to avoid that they are in the wrong hands. And I was asking them, but why do you think you are the right hands, you know? And so I think it would be very super interesting, and thank you for working on that, to have these decision-making models, like helping them, because probably it would encourage more violence, because if human lives are not at stake, which was their point, we have to protect our army, our soldiers, whatever, but then this can encourage even more violence. And if not everybody, not all the countries have these technologies, then there is even more inequality. So I think it's a super interesting point, and just wanted to say that at the high level decision-making, I don't really think they are going in the right direction, to be honest. So.
Yeah. I mean, the world needs help on decision-making for sure. Okay, well, thank you. Moving on.
In our mandate, we work on the economic and social. Our use cases are driven primarily by requests from the member states. So some of the use cases that we've worked on that have gained a lot of attention relate to social expenditure monitoring. So how we can use AI, for example, to study the national budget, the projects that they do on social protection, and then try to optimize the allocation of funding by understanding the interlinkages across different expenditure classes. So this is one. Another one is
By the way, on that one,
Sure.
I noticed that a lot of like at least local budgets are available, like they are published and the data is available, and actually you can get historical data on them as well.
Correct, yes.
Which is just food for our type of modeling.
Oh, absolutely. And when we have challenges or sensitivities around that, in terms of the level of data they provide, we work with them in terms of building the model within their own environments so that the access is strictly to them. And then and with NDAs and all of this, and then they seem to be more willing to share more in-depth data than what's published on published basis. The other one is we worked with on a use case for trying to bridge the gap between the supply and demand side of the labor market. We analyze job offerings, capture all of them, you analyze them, and then try to not only show the skill matching, but also ensure that the policies they're developing are more, take into consideration gender bias, the inclusive nature, and then we bring a team of economists to help based on these outputs, based on the results of the predictions and the results of what kind of matching gaps there are, the policy recommendation comes in. And a third one was around improvement.
And it's policy recommendation on both ends, like supply and
correct.
demand.
So for the Ministry of Education, what kind of output workforce is required, and on the demand side, what kind of job description, including, for example, changing the nature of how jobs are advertised. And things
that relates to education as well in
Yeah.
some ways, right? If there's a gap, that gap needs to be filled.
Yeah, and
It's very interesting.
so we have that, and then the third one on improving national performance against international indices. So countries have these, the rankings of the different global gender equity and competitiveness index. So what they're trying to do in these ministries of planning, for example, is they have a mandate to improve their performance across all these indices. They have limited resources. How can we, find the correlation and the linkages where we can just press the button with the money we have and have the most impact across all the indices?
Right.
And so we built some models for them on that area in this. Another one on poverty, for example.
You don't get 4 use cases, man.
I don't. I'm just trying to throw them out to make like. Sorry, not to. Just to give. I don't know.
Go ahead.
The last one I'll do. MPI on a multidimensional poverty, where we're using the satellite data, nightlight, and yes, we're using nightlight and daylight as well to look at improving prediction of poverty rates, and working in that area. So these are some of the use cases.
And does this imply that it's in that order that you're in like priority interest? Is
No,
the order you recounted them, or it was just
No,
came
it's
to your
it's
mind?
where we've worked on around 52 use cases over the past year and a half.
Okay.
These are let's say the top 5 where we've had interest from more than 5 countries. Yeah.
Oh, all right.
And there's a lot of work in them that's distributed. So this is
Very interesting. I'd be very interested to learn more about all of these use cases and the data that you guys are actually have collected and the experiences that you've had.
we have them also publicly available. There's for them we created a data and policy support hub.
Yeah.
The capability was given to them, and then it's available.
I wonder if we can actually have like a distillation of a lot of these in some central, maybe through the ITU website, where we can actually list these types of decision problems that you guys have worked on. Great, thanks.
I don't have anything for the moment.
What?
Sure.
Okay.
Okay, so
Okay, no problem. Let's move on. Yes.
Well, I don't actually have a system yet.
No, you don't have to have a system.
Yes.
It's an idea. If you have an idea for a decision problem that kind of roughly
Yeah.
fits. Yeah.
I run the One Goal Initiative for Governance. My name is Aleb Mine. And indeed, it is about decision making, and it is based on a observation that our system and our governance is our approach to governance is intrinsically unsustainable. It leads, when we're talking about this just before, it leads to an unstable situation, and damage is happening as we speak. It's only going to get worse. I'm sorry. Now, with regard to what I could say about what should be done, maybe a couple of things. One is we should model what we don't know. So every time, at every level in the model, you want to say, okay, there's this, and there's that which we don't know. So you want to have this integrated in the model. And this may lead to a situation where we perceive at some point a shape in this unknown. When we look at the entire model, I don't know, but it's possible. And there was this other issue, which was we need to really become aware of our assumptions. When we create a model, we start from, okay, what is it that we want, right? But that very question we're not able to answer because we don't have the right model to answer that question to start with. So that's why we need to become very aware of the framework, starting from which we create the model. And also,
so what is an example of that? What is an example of a use case in which at the get-go we don't quite know what we actually want?
Oh, we know what we want, but we don't want the right thing,
I see. So we might actually decide after a while that, oh wait, this wasn't exactly. I think you had an example for that.
Yeah, exactly.
Yes.
Right.
What was
So
it?
at a local level we want to change land use, but that land use in England results in a case of more emissions in Brazil, for example. So and then we have to modify it. Actually, great. I think we answered our own question.
Yeah. And about what you were talking about the weapons and peace, etc. Peacetime leads to war. So if you do not want violence, you want to have dynamics during peacetime that are sustainable. So that would be my thing to you. And about when you said let's agree not to help any decision making, and that's it. On the contrary, you want to go in and make the decision. You want to tell each autonomous weapon how to make their decision, and it goes as follows: do not take the hit.
Okay, so we should infiltrate and.
Yeah, there you go. Exactly.
Okay. Great. Okay, let's move on to, I can't see all the way back there. Yes. Use case ideas, please. Yes. And if you weren't here when we started, please start with introducing yourself.
Hello, my name is Konstantinos, and I work with a project that builds wearable brain-computer interfaces. But in fact, the addition that I wanted to make was to build on your comment from before, and to say that what you said right now sounds to me like the alignment problem as well. So we might even know what we want, at least at first approximation, but in the way that we model what we want in data and in the training objectives, we will end up with a model that does something sublimely different.
Mm-hmm.
And I guess that this is a well-discussed subject in technical circles, but how does this awareness, which might exist in technical circles, bubble up now into the discussion that we're having on this table?
Yeah, although the topic here is really to brainstorm on use cases, but we should definitely take these ideas, and they're helpful generally anyway. But do you have any thoughts on actual use cases as well for decisioning? By the way, I think some of you guys weren't here when we started, but the way we framed it was, it's some local decisioning that's already happening. For example, education resource assignment, for example, and we're trying to improve levels of education and optimal resource assignment, reduce cost. But it's a problem that everybody has, like around the world. Education is pretty global. So if we can identify these types of use cases, we can then harness this local energy in solving these local issues into a global decision system that can benefit everyone. So that's kind of the,
Maybe some context because I wasn't here in the beginning.
Yeah.
Have we discussed about policing? And
no, which is great. Yes.
yeah, in fact, this is something that I guess also from pop fiction is something that has been discussed a lot. But
Or from France from last week.
exactly. So how do we take this very active subject now and have a rational discussion about it?
That's awesome. I love it. So yeah. So go ahead.
No, and I think that example just reinforces the point that these verticals are never actually siloed, right? Because if you're talking poverty, or if you're talking in many cases, anyway, for instance, if you're talking poverty, you're going to end up talking crime as well.
Exactly right. Yeah. Can you? I know we're kind of running out of time, but I love that use case. But let's just to give everybody else a chance. I'm going to stop asking questions, but I love the use case. We should double click on that. But yes, next.
Brief introduction
Yes.
of myself. I'm a PhD student at EPFL, and I don't work on this kind of issue, but just interested in. I feel like the global decision platform is very important, but perhaps just different nations have their different interests, and how to collaborate. Perhaps it's a long-term discussion about this. For example, the international organizations, how do we involve more countries' efforts, or and so on. So definitely many people need this.
Do you have any use cases in mind?
No.
Okay. Thanks.
Yeah, I can fully subscribe to, what was your name again? Yes, Georgina's comments earlier on the use cases, that we really have to work with like the people on the ground, be it NGOs or government officials, or whoever, you know, is really affected, and then make sure this movement up and down, like of information and what it makes, what it changes is there. If I have a wish for a use case, it would be something that helps us manage trade-offs between different SDGs, in particular the obvious environment, poverty, income trade-off. But I have an example for this up and down movement, because we're the consultants who usually then implement this use case, right? So we get the use case and then you have to do that. So we had a use case, I'm not revealing which country it was, to make them keep their face. We had a use case where they asked us, okay, so we need to know better what SDG initiatives are happening in this country, and they need to coordinate better, like all these little NGOs, and they need to coordinate better. So please build us a platform that helps them coordinate. And then we went around and asked them, and they said, "Oh, we know everything that's going on around us. We know all, it's a small community. We know everything. Why should we subscribe to a platform, keep our information, like send our data there and keep it updated, since this is very dynamic, you change initiatives and activities all the time. And why should we do that? No, we won't." And the discussion went on, and we figured out, okay, no, the use case was the government wants to know better in order to be able to steer budget allocation, like funding towards certain SDGs. They wanted to know what's ongoing already regionally, like per city and district and whatever, but also where's the focus in terms of SDGs. So there was no use case on the local ground. The use case was with the central government wanting to steer. And that's where AI came in, because in the end, we built basically a crawler that harvests the information that these initiatives put online and tries to categorize them and makes them decision ready for the government. And here's the next risk. One risk related to that is that if we don't know exactly how the information is built, we may give wrong advice, because our model may say, hey, there's everyone working on SDG 1, but that's in this case because of the language conventions used in this scene. It's not because most people work on it. So we have to be really aware to allow feed it back and say, does this really represent the true ground truth information, and back and forth.
Right.
Sorry.
Great. Cool. Just real quick, because we don't have time, we'll have to just.
Really quick. I'm Tanielle. Thanks for having me at the end. I managed to get an earlier train, so it's really interesting to join you all. I think that's really interesting. I think we should all remember it's not in everyone's interest to have their data archived and slewed, and that's something that I think we should bear in mind. I'm actually a weapons expert, AI and weapon systems, so I really enjoyed that conversation. That's what I do.
Kick her out right now.
Oh no, I'm about regulating and banning certain uses. I just gave evidence to the Lords on why we shouldn't be using it without regulation, or banning certain uses. And one thing I would say very quickly before my use case is when you talk about not helping and decision making, one thing that I've noticed in governments and a lot of MODs is because they're not mostly technologists, they don't understand the unpredictability, they don't understand the inability of the decision-making. They think political decision-making, they think it's the same as variability. You know, a gun's bullet will go a bit up and down, or it might not hit very well. It's not the same as AI's unpredictability. They don't understand it. So for you as technologists to really hit that home, it's not going to do what you want it to do reliably because of the way data is trained, because of overfitting, things like that. If you can keep getting those things home to them, it would really help us. So I would just say that because they've just clearly not understood that kind of unpredictability. They just say things like, well, war is chaos, not that kind of chaos. My use case would be in outer space, AI, which is used to for near collisions to help maneuver satellites like debris cleaning to prevent collisions. That would be my use case.
All right.
Over to you.
Thank you.
I'm going back to the topic of education. So jumping from weapons to education, as Nelson Mandela has said, education is the single weapon that can be used to change the world. This time I'm going to talk about, rather than resources, about curriculum. It's still at the idea stage, but what we are doing is we're creating through generative AI tools that allow kids to learn faster through games, through visual education, and so on and so forth. And we have built also an adaptive learning system that allows kids to kind of content to adapt to the need of the kid and the way he or she is learning. We want to use the data that we are collecting on them, how they are basically comprehending different kind of information and content, to be used for curriculum building and showing if certain subjects should be taught in a more, for example, project-based learning or more traditional-based learning, or in a more visual way or more gamified way, so that they can adapt it. Or if curriculum, for example, is too heavy for them or too complicated, so the policymakers can adjust the curriculum.
Very interesting. Thank you. Thank you. I'm sorry, we kind of got a little bit rushed on the latter half. But I think we collected a lot of very, very interesting use cases. There she is.
Okay, so we are going to start with the first breakout session, which was about use cases. So Georgia is going to take it away for roughly 5 minutes summary of the discussion, and then we can ask questions. Are you ready?
Thank you. Great. So we had a very interesting discussion on use cases. Different people explain different use cases. I will mention a few of, well, I think it's all of them. Some projects are working on decision making on agriculture to improve the crops that are being cultivated in different places, so that it contributes to climate change and there are not intensive crops that then become damaging and are not positive for feeding the population. Some other projects are on poverty decision-making, providing governments with inputs to make the best possible choices in order to mitigate poverty. some others, there has been some discussion on autonomous weapons and also projects on education. And also I found quite interesting that somebody mentioned about the connection between different SDGs, because really we've been working on specific topics, but many or all of the SDGs, of course, are connected. So it's also important to consider that. Then there were some general topics that were raised that affect all these use cases. One of them is the fact that we believe it's important to work bottom up, so that really we work hand in hand with NGOs, because we are here, you know, in this institutional building, but we don't know the real needs of the people who are suffering or who need support in these different areas. So, but there are specialists that do know and that are working in the field. So it's important to work with them so that we identify what are the real problems in the ground and then construct these AI decision-making helping systems based on that. Another point that was raised is AI for what? You know, somebody said, we know what we want, but we don't want the right things, right? And I thought that was a very interesting point, because we focus a lot on the tools. AI is a tool, but a tool for what, right? And we're working towards SDGs, but also we have the opportunity now integrating AI to revisit what our objectives are as society. And that's a great opportunity we have as human beings. And another point was careful with the data. We know that AI is overestimated. We provide this information for decision-making to governments, but if there are mistakes, you know, if AI is overestimated, this can have really bad consequences. And also, I think here, the point that was explained before on open data is very important, because not who has this information. We build these systems for decision-making for governments, but if we only give the information to specific government officials, or, you know, information is power. So it's important to have open data so that also the population, NGOs, all the stakeholders can have these predictions, these simulations, this decision-making, this information that can help us through AI for decision-making. So, and finally, I will just mention that we also talked a little bit, although it was not our topic, about technology, saying that it's important to integrate different technologies. I think it's very interesting to combine, whenever possible, different, like machine learning, but also agent-based modeling and all other technologies, because sometimes it seems that AI is only machine learning, but there are many other technologies and methodologies that we can use. And I don't know, I would like to ask my co-team members if I forgot something. So. We had cookies. And we had cookies.
Thank you. So anything anyone wants to add, or any questions?
What was the topic on autonomous weapons? What exactly was the use case there?
That's a very good question. And that's the person. There are two people in the team that are here, I think. I was very, one of the points was there was a lady who was saying that she, you explain it much better than me.
Hi. What was it you wanted me to, it was quite a general point.
Yeah, I just wanted to know, because it's a autonomous weapons is a use case, but I'm not really sure what we're trying to do there. What is the goal? What are we trying to have to accomplish?
I think the general feeling in the room was not to use AI irresponsibly in weapons. A colleague raised the issue of the problems of responsible decision-making in AI, because AI is unpredictable. You have issues of bias, you have issues of overfitting in training. I I'm an expert in AI and weapons systems. It's what I do, is weapons technology and regulation. And someone said, well, we wouldn't want to be part of using AI and weapons systems. So we talked about the problem of a lot of policymakers and weapons developers and military users who don't understand, who aren't technologists and don't understand what unpredictability is, and what chaos is when it comes to technology and data. So we were talking about the fact that when you're technologists, that it would really be helpful if you explain the fact that the kind of overfitting in data and underfitting, the fact that lab test scenarios, the brittleness, the degradation from lab tests to wild environment scenarios can be quite dramatic. And I can tell you that war is the noisiest and most chaotic scenario, where 9/10 of the time it's very quiet, and then 1/10 you'll have a spike in noise. So when you have pattern finding, you have something that's focused on pattern finding, and then you have an anomaly. If you have smoothed out data, then you're not going to see it. And it is the most problematic thing there is. So you have a lot of weapons developers over-promising their technology and having huge contracts based on that, which is not only deeply immoral, but they're over-promising technology that I know that they can't deliver, because I'm both a technologist and have a background in human rights law, and I've been to the front line. So they're talking nonsense. It'd be really helpful if you could get that across to them. Thanks.
Okay, thank you. So the use case was not to develop weapons, but to actually mitigate this. Talk about this problem. Okay, very interesting. Thank you. Any other question? I think we can move on to the next breakout session that was about collaboration. Who is the speaker? Take it away.
Well, I have to start with a disclaimer, because I broke up the silence of after the question who would be the speaker, trying to explain that English is my second language, so I wouldn't be the right person to do. And here I am. So I apologize for the mistakes, and I apologize if I don't represent exactly the idea of the group. But let's start here. So in order for the collaboration and the engagement, we should state very well the big picture first. So stating the challenge, the objectives, and the benefits that it would be the project, right? It would bring the project. Then identify very well the stakeholders and the barriers, like the sponsors, customers, users, government, the experts that we work on, and the volunteers as well, the academic persons and so on. Then to plan the communication, because we have to prepare and plan exactly the communication to adapt the right communication for each sponsor, each stakeholder, sorry, that we mapped. Different communications for each kind of stakeholders, and look for strategic partnership, partnership that would bring reputation, that would bring trust for the project, and so that the engagement could be more strong. Then resource and time, right, to state the milestones, look for the data source, who will be the implementers, the data aggregators, all these issues, and one that we just brought here, that the accuracy of the data that we are going to capture, and to define an agenda, an ongoing continuous engagement, so that we could present results, difficulties, and needs, and demos, right? Demos of what is happening, like we had here, contributions, new contributions, the feedbacks of the stakeholders and the persons that's participating, so that we could have an actualization of the context in an ongoing way of the project. That's it. Thank you for the opportunity.
Thank you. Anything anyone wants to add?
Yeah, I think that was a very good summary. The one perspective was that like the partnerships are important, strategic partnership to form before the all hell breaks loose. So this is something that hasn't been happening and it will take time to build. And that means that we should start now in order to be ready when something happens, like a pandemic, for instance. Depends on the use case, of course, but that was an important perspective. It's an ongoing effort, not something that's a reactive effort.
I do have a question. And of course, as you just mentioned, you know, the partner depends on the use case, but do you see like any new type of partner emerging?
Yeah, so one thing that came up in the discussion was the data aggregators, that's a new job that doesn't really exist. And, you know, there might be, depending, of course, again, you use the hospital, for instance, or educational systems or government, they do produce data. But there's a new job of bringing that data together so that we actually have all the data we need accessible. And that is, nobody's really doing that at the moment. And I don't even know who would be appropriate. I mean, would it be a government organization? Would it be something like, I don't know, ITU, United Nations, something really big organization, or would it be maybe even for profit? But data aggregation is a job that hasn't really been defined or built yet. And that is actually something that all such applications need. So that's one such role.
I would imagine it goes beyond just aggregation, it's harmonization, right? And being able to track, for example, the policies and actions that are taking place and harmonizing them across, like Toby was describing. Very interesting. Yeah.
Sorry. So in the international development sector, you do have such aggregators. So in education, we've got UNESCO Institute of Statistics, and they do a great job, but they keep getting their funding cuts. So quite often I see, certainly in education, we kind of reinvent the wheel. So the challenge for me there is, how do we take, they usually just deal with the headline statistics. How do we get them to move down to aggregate the kind of data which we need here, which I think Olivia said earlier, you need granular data. So I think certainly in the international development space for education, you have something. It's not fit for purpose. So I think the question is, how do we work within the current framework?
Yeah, which actually harkens back to what we were saying, which is partnerships in which you actually demonstrate the art of the possible. You show them that, you know, here's what could be built if we have the data, and then you know, that would incentivize them to go off and collect the more appropriate data and more granular data that we're looking for. I think these days with generative AI, we can actually even fake a lot of the data and take it to these guys and show them and say, you know, if we had this kind of data, then we could produce this kind of decisioning, for example. So we're not starting from scratch that way. Yeah, very interesting.
Okay, thank you. I think we can continue with the third session. That was the technical session.
Okay, so can you hear me? So yeah, so hello, I'm Janko Mursik-Vogel from Planet Computers in London. So it was a small group, about I think 6 of us at the group 3. We focused on essentially what would be involved on having an AI application, and the 3 cornerstones of the application were data, the model, and the UI, the user interface. We extended that further with infrastructure on one side and tools on another side. I'll go into that very briefly into each of those. So in terms of the data, Professor Lee from Liverpool has outlined the sort of 12 steps. We touched on that, but we also needed to understand sort of what's the context, and also if there's some historical information. And then when we came to the model, we're looking at both predictors and prescriptors in terms of what's going to happen. So the predictors take the context and an action and create an outcome, whereas the prescriptors take the context and suggest us an action. Of course, very important in all of this is metrics, APIs, and traceability, which we talked about. And then the question arose about APIs, who has the ownership, and also are the users paying for something, and who are the owners, and who are the users. Then we went into the software supply chain and discussed whether blockchain would be a good technology to underline some of the transactions, because some of those resources might be allocated ad hoc, and there's a dynamic allocation of resources depending on the problem, even depending on the data. So we touched upon the collaborative side, also volunteers, incentives, and reputation building, and how is the and validation of all of that, and touched upon as the tools that are being used to make sure that good tools attract a lot of people as well. And of course, standards were mentioned as well. Going to the infrastructure side, we mentioned a few things. One is that we should try not to be vendor dependent. That's a lot of solutions today are vendor dependent. Questions around about open source and also open training data sets. And then whether we have decentralized or centralized infrastructure for those services, and what it would also mean for the decentralized services to be completely democratized. And that's probably about it. But the UI side, just on the UI side, yeah. So Brigitte told me about this. Yeah, just go on the UI, because I think you covered that one.
Yeah, there's three pillars, there's three pillars: the data, the model that we cover, and then the UI, which, is important to have the user interface to be able to use the models, also to compare them, and even to add some regional context, to the data, for example. That's all.
So that's about it. Yeah, thank you.
Anything to add? Or any questions? Oh, sorry, go ahead.
Okay. I think in the UI side, we couldn't go deeper, but you said at the beginning something that is very interesting, that the UI side has to be created to help decision makers. I have tried everything to have my decision makers to use my tools, and I think it's impossible. Maybe you have to create something to help the person who works with the decision maker to print it and give, at least for the next 20 years. This generation that is managing, I cannot see them going to a website. Is always only 99%. Probably there is someone somewhere that is able to go there and check the facts in a UI and take a decision based on that. The rest is like paper-based, which means that maybe in the UI side, we have to think in how to create things to help these users in another way, because they are not going to go to the screen to take a decision. That's my feeling and my experience.
Yeah, that's a very good point. And that's why also we need a different set of skills to develop these UIs, and probably to partner with the decision makers themselves to actually build the applications they are looking for, and iterate with them so that they can actually use it. Yeah, that's a good point. Another thing we talked about is that about the dynamic supply chain that also applies to volunteers. One of the issues we had is that the volunteers come and go. They are not always committed 100% to the project. So it's very important to have some ownership on these different sections and make sure that when volunteers disappears, there are some incentive and some ways to recruit new volunteers to continue the work.
I'd like to continue a little bit about the UI. What is the problem? Is it really that this is a generation that's not comfortable with using, say, web-based interfaces to AI systems, and it might fix itself when there's a new generation that's educated with it? Or is it just that our UIs are just fundamentally different from what needs to be done in this domain. I mean, what's your impression of that?
The private sector and then 10 years in the public sector. In the private is maybe a little bit easier, you know. Why? There is a continuous learning thing probably there. Yeah, they cannot be stuck in the public sector. You get your rights, no? You are here and you will be always here. You have to do something extremely wrong to be fired in the private sector, in the public sector. And then at some point they stop to learn. And they have the right to take decisions or suboptimal decisions based on this method. Yeah, with some advice, yeah, but not I don't see they focusing in spending one afternoon, yeah, going through a tool, clicking here. I do very easy and nice tool, but it never works. Yeah, or having somebody who explained that to them. I don't know. I tried everything, you know. Go ahead.
Just to interject on that one, you know, it's when you're saying the you got to really live, you got to get the decision maker to kind of live the data to understand where those inflection points are and where the things are changing. Because if you take a simple example for an everyday citizen, you have a look at it like a mortgage calculator, right? Then you can see that curve and they can just kind of understand it. It's okay, it's a single variable. But you know, if you look at then a multi-variable system, the manager still needs to kind of know, the decision maker needs to know. And it can get complex, but you should kind of feel the data a little bit.
Yeah. Hi, I'm surprised with, or maybe I just missed it, that all this conversation with AI, we haven't mentioned conversational interfaces. I'm seeing a lot of decision-making projects start to have good success with that, exactly because it starts to break through that barrier, right? It's something that approaches more the kind of back and forth and dialogue and the clarification process that people are familiar with. Has its own drawbacks, like it's for communicating with people that have more or better visual thinkers, for instance. It's not necessarily ideal, but it works. I also wanted to add a small anecdote. This is not firsthand experience. It's from a friend, but it mirrors a lot of what I've seen in this private sector, but large corporate. My friend was a strategic advisor to a CEO of a large multinational, was talking to the CEO about insert strategic topic here. And then the CEO was like, I don't know the data about this. Let me call in the division president. And in walked the division president with a stack of paper and pulls up a chart. Here's the pie chart that you're looking for. And the CEO says, if I see any more of these pie charts, I'm going to throw the person out of the window. So this, I don't think it's about the visual versus textual. It's more just around people don't want charts; they want answers to their questions, right? They want advice that's tailored to the specific issue that they're talking to.
I wanted to say I tend to disagree, but actually now I agree because I don't think it's the user interface or whatever, and we underestimate our old colleagues. Because I think a lot of them are quite good analytically. And when I worked in research, all these old professors that, still did their calculations with almost on paper, they were really clever. The problem is they really want to dig. First of all, they want to have their questions answered and not we start from the data, we display what's there. But they want an answer to their question and not all this data that they don't need to answer that question. They only want that part they need. And we don't listen to them what they need, I think. Yeah. And the second part is then they want to question it. Then they want to say, okay, with all my experience, I think there could be a flaw. Or why is it like that? But because we give them the system, they have no one to ask the question. Mm-hmm. And that's why they call in someone. Right. To ask the question.
Yeah, And
So I
then
think we need a way that they can interact like with a person or with a chatbot or both to ask their follow-up questions when they are hooked on.
and then there is the pass the buck use case when they actually don't want to make the decision and want somebody else to tell them what the decision should be.
That's
It's
also
very
happening.
hard to disentangle the two.
Yeah, that's true.
I'm gonna leave it at
So it sounds like a couple of things we could do is to pay attention to making this kind of systems explainable and explorable and interactive so that they are working with the decision maker and they have a way of understanding what's going on. And maybe part of that is also education, that we have to educate these folks that what these tools can do and cannot do. So it's not a mysterious black box for them.
And then don't blame them if they don't use that, if they think it's not usable because it doesn't answer their questions. Then we have to go back and work on them.
Like a conversational AI, actually, that you can question based on, we can question the data and ask all the questions you want.
And that's easy, by the way. You can do this with vanilla GPT-4. No mods required.
Actually, one thing. One thing we found useful in our engagement with the member states and the use cases we work with them on is, plugging yourself into their operations as opposed to trying to drop the tool into the standard way. So for example, one thing we do, a lot of them want to work on VNRs, these voluntary national reviews that they have to submit to the UN. So what we did is built this capability into the tool for them, even if it's a side module, and then try to get that analysis from the tool itself and showing them that, what used to take, this report used to take you 2 months with your team to produce. Click these buttons here. And when you get to the point where there's analysis on the impact on SDGs, here's how the new tool fits in, and you click through it, and then it produces a PDF in the format of the country itself. And when you do this, more and more as we went through this approach, by plugging ourselves into the product, there was a lot more interest, a lot more engagement. The other component was, and one what we hear a lot is, we don't necessarily, let's say, think that UN data is the most accurate through the representation. So if there was a way for us to integrate our own national data into this model, into this approach, then we would have more incentive, even from the local decision makers who refuse to use data beyond national data, for example. And so we work with them in that and customize it in that manner. And that helped more adoption in some of the use cases we discussed in our earlier session. So.
I actually wonder how much of this issue is an issue of putting the onus of decision-making on the decision maker, which means that what we as data folks and AI folks are doing is brokering a plethora of reports and stuff like that, and throwing all that at them. They're already overwhelmed trying to make the decision. And yeah, in that case, of course, if they ask the question and say, this is the report I want, then it makes it a little bit easier. But I would even take it one step beyond that and say decision making is not easy. I think one of the things we should convince our decision makers is that decision making is not easy, especially if it's tackling more than one objective at the same time, and that they can actually rely on the AI system to answer specifically the question, which is, what should I do, versus, here's a bunch of reports, go make heads or tails of them.
Maybe another way to say this is that decision making doesn't end at the decision, right? It's a continuous process where, like, as a decision maker, you're one way or the other, you're going to have to live with the consequences of your decision, right? Or your successor or your stakeholders, and you're going to get questions, and you're going to have to follow-ups. So rather than just thinking about it at that point decision that needs to be informed by data, think about it as a continuous process where the work is really to form a rationale over time, where it can really, talk about explainability of AI, but what about explainability of the decision, right? Well, we chose this despite knowing that there's all these negative effects, because it turned out to be the best choice that we had at the time. And then, of course, afterwards, we learned better and so on. And being able to tell that story, it has all of a sudden you're taking it from hey, here's a lot more stuff that you have to take into account as a decision maker, into hey, here's a bunch of tools that you can use afterwards, or when you're communicating your decision, when you're revising it, when you're covering your ass and making the next decision down the line, right?
don't take me wrong. Then I didn't say that my decision maker was that or something like that. I say
That's what we heard.
because they had questions.
Sometimes it's not more data that gives that leads to a better decision. Sometimes you really do not need to know much in order to know where the system is going. And I can give you an example. When I was in New York, short before, like maybe a year or two before the 2008, crash. Somebody I know who worked at a bank told me that his bonus he was selling mortgages, did not depend on the quality, on the capacity of the client to pay back. It depended only on the volume that he sold. So that's clear. I mean, you don't need any other data to know what's going to happen. I wanted to say about data. There's one concern that I have, which is if you have data entry made by humans, especially about the reasons for things like causality information, then there is concern that these would be inaccurate. So therefore, whatever decision we make with the data would be misguided. How to address that kind of problem?
I don't have an answer for that. It's a problem we have with data. We know that the data we collect is usually biased. So I think I don't know, maybe the best thing we can do is collect. Yeah, I was going to say collect data from different perspective and get diversity in the data itself and not focus on just one source in order to try to gather as much as possible and try to make sense of what's been gathered.
Thank you. Yeah, this is something we grapple with the whole time in education systems, because quite often schools get paid for the number of children they have. So we know the enrollment data is artificially inflated. So what we try to do is ask, well, what is the direction of the bias, and are there any statistical controls we can be doing for this? If we assume everybody's cheating equally, then you can net out some of the things. So a lot of what we try to work people through is just kind of like, okay, well, what is the possible bias? Is it just noise that we're introducing or weakening the system? Or is it the case that certain subgroups will cheat in different ways, in which case you've got distributional effects as well? So I think most data is biased for, recall, desirability bias when you're talking to people. Understanding why and how it's biased can help you find the right statistical correction. And sometimes it's literally just living with uncertainty. Just coming back to the point the gentleman made, one of the things I often say to kind of new staff members is we work a lot in policy, and in policy, if you have a 95% accuracy, it means you're wrong 5% of the time. If you're in, say, India and you're advising on education policy, you're wrong for 10 million children. So is the politician going to accept being wrong for 10 million children? Probably not. So the kind of bar for accuracy is really high for politicians, because that 1% that's wrong, they can see out on the streets rioting, so they're always thinking with that. Whereas like data people were like, oh, well, you know, it's a statistical significance at 95%, or, you know, we've got this machine learning model with like 90% accuracy. If I say that to a minister, they're just like, you're wrong 10% of the time, get out of my office, you know? So I think it's just that realism of where they're coming from and tracing it back to the number of people, essentially, that's affected. Yeah.
Can I make a comment on the bias too? Because there has been enormous amount of research on bias in AI, trying to debias it, etc. And also most of the conversation of fairness in AI have been focused on bias. But according to cognitive science, we are all biased. Human beings are biased because we interpret reality based on our previous experience. We put information into categories because we cannot understand every single detail of every single person. Therefore, we have prejudices and we are biased. So just to clarify, there is nothing like debiased or debiased AI. This is a false assumption. And any data that comes from humans, because we are biased, is going to be biased. We have to live with it. And that's why I think it's important to work interdisciplinarily, so that we work also with experts on social sciences, and so that we evolve as a society and we can mitigate biases in general, not only in AI.
Yeah, and just one thing to add there is that we need to think about the baseline. Like, what are we comparing ourselves with? Is it the ideal? Are we comparing ourselves with God, like, you know, never fails? Or are we comparing ourselves with a decision maker that's not looking at sufficient data, does not have the models, even though the data might be somewhat biased and models might not be accurate? But would that still be better than, you know, what you just, the gesture that you made about the politicians? So I think we need to look at that baseline and whether we stand to improve it with AI-based decision making.
Well, but the problem, of course, is that even though we and a lot of other people may understand it, for the decision maker and for people around it might be an opportunity to say, hey, it's not my fault. I just followed the AI's advice, right? Right. And so there's a best.
Yeah, actually, that's a really good point. And that might be what helps us finally get through and have the politicians make use of these systems, is by showing them that they can actually blame the systems for mistakes. Yeah, maybe, I mean, hey, let's take some responsibility here, okay? Yeah.
I think we need to take the perfection as our measurement. That's
I like that. In the last weeks with the generative AI, or the last month, I have identified a new type of bias that can be partly corrected. We are training our generative AIs with documents written by humans for humans, and which means that there are things that they don't understand. As example, in our huge meetings in the COPs, you know, in these climate change COPs, we have to type, basically, we have a lot of actors, but there are two that we can differentiate. Parties, means countries, people who represent countries, and people who represent NGOs, companies, and so on and so on. Of course, parties have access to absolutely everywhere and everything.
Great ringtone.
And yeah, but the observers, they don't have the same rights. Okay. Then in our policies, we have this thing of parties and observers can do this. Parties and observers can do that. Parties and observers can, but then at some point somebody decided that this sentence were too long and start to say parties can do this and sometimes observers can do that. But when you say observers, actually you're saying parties and observers. But the AI took that and we create a vote for some exercises. And of course, they have their own rules where they have both things and then start to have one or the other and start to say, observers can do that, but parties cannot do that, you know, because the text is written for humans. And we understand perfectly that parties are allowed to do absolutely everything. And then what is the solution? One solution is to start to create documents more for machines than for humans. Put 100 times in the middle of the text, parties can do everything, parties can do everything. Because if I put, somebody said, we can put at the beginning, said, no, it's not gonna be so intelligent. Yeah, but if you put at the beginning with 40 size font, no, it's not that. That is also for humans, no? And this bias can be partly corrected if we start to train our new systems with something that machines can understand a little bit better. I think a lot of bots have that problem. And we are not going to put never ever a public bot. That I can tell you. Because one mistake is that the politician. One mistake is enough to receive 1,000 emails saying, oh, what are you doing? Yeah, sorry. Thank you.
One concrete challenge that we have to do as modelers and talk to anybody, also decision makers, to communicate uncertainty and probabilities and what that actually means. Because people generally don't really have a great idea. They may be familiar with weather predictions and the uncertainty that's fundamental in weather predictions. And they've gotten a lot better, but they are willing to accept that sometimes the weather predictions are wrong. And that kind of communication, whatever we are predicting, I think we should do a better job at that there is a range of possibilities. And these are the likeliest one, but there's also a chance that something else will happen. If you can communicate that, there might be a better adoption and understanding and maybe like a assignment of credit, and the decision making can also be better informed. But that's still a challenge, how to do that right.
On that front, I think whenever machine learning models are developed, there's model cards which are associated with it. And there is an increasing discussion in the ML space that this is different from the classic explainability problem and interpretability problem of machine learning models. Model cards describe the details of how this model was built, what are the variables that are taken into account, what happens when you tweak around with a few of them, and building that out in a way which is understandable for the layperson. And combining that, like not everyone has to be a machine learning model. There are plenty of no-code AI solutions, and that also goes into the point of the UX UI design. You don't really have to go through a whole array of tabs and selections and drop-down elements. There are companies which are building that out for you. And imagine combining that with a conversational agent and a sufficient level of explainability built through those model cards, which a layperson can understand. I think the time to train someone to actually use these systems can also significantly go down. So I think there's definitely room for doing that. And there's an increasing understanding and acknowledgement of that, but there's still a bit of a way to go. It's like the classic IT OT problem back in the day. If you were going into a factory floor and starting a digital transformation journey, not everyone on the factory floor and in your operations team would understand the digital transformation part. And a lot of the booklets that were developed initially, they were super technical. And over time, they were built out in a way where my operations manager on the factory floor, who doesn't have a very deep technical background outside of the machinery, would also begin to understand it. So I think that bridging of gap will also accelerate the time of adoption, and you don't have to go through a super lengthy training process to train the people.
Thank you. I think it's time to wrap up the reports and move on to the posted session. You want to?
Sure. So we're gonna dive right into posted sessions. You guys, we've distributed some post-its around, and if you can't find any, there's more here. You'll have to open the wrapper, which is not very easy. And there's some post-its here as well. So the themes are corresponding to the breakout sessions. So if anyone has new ideas from their own breakout sessions or has ideas to contribute to the others, please go ahead, write them on the post-its and post them on there. You can mark them as priority items. For example, if it's a use case that you think is really, really important, you can put it up there. Ideas that you have, feedback that you have. And then under other ideas is everything else. And we realized actually very quickly during this workshop that there is these three categories clearly don't cover everything. So other thoughts, other ideas, feedback, comments, go on the other ideas page over there. And we're going to take about 30 minutes. All right, we're gonna start wrapping up. The way we're going to do this is each session lead is going to very briefly summarize what they see on their respective boards. So I guess I'll start. So on the use cases board, we have a number of use cases and a few ideas as well. How to keep peacetime sustainable, which is a very noble cause, I think. We have the education one. Actually, the one that got the most votes is generate reusability for items instead of throwing them. So I guess that was inspired by all these bottles here. Where to move. So this is a really interesting one. Where to move and how to change our lifestyle based on location and people. So this would be useful. I mean, we keep talking about institutional decision makers. I like this one because it's like a personal decisioning system that's quite interesting. And I guess that could be a opening for a whole bunch of other decisioning systems too that hit us directly. Maybe, for example, home energy management and decisions would be another one, you know, those sorts of things. Surgery based on context, action, and past outcomes is another one. Okay, this one got 3 votes as well. How to manage the end of primary resources like gas and energy. I think reducing our reliance on fossil fuels. Education, I know who put that one up there. Resource allocation in new schools, both quite interesting. I think we had curriculum too. It didn't make it to the board, but that was captured in the use cases that we talked about. And how to inform management of
migration flows.
What is that? Migration?
Yeah.
Migration flows. Okay, so immigration flows, I guess. Okay. All right, awesome. And a few more with respect to water management policy, ecological diversity, municipal budget management, fishing management. So very interesting. For one, after this and the breakout that we did, I was not expecting coming into this having so many use case ideas. It's really cool. I mean, the devil's in the detail, obviously. We have to look at whether the data exists or not, whether there's any patterns in there where we can do some predictions, whether the decision maker is even interested, and we can bring them to use them. But it's a great start point.
When we have to solve everything, it's all connected.
Yes, but we do have to solve everything. So our work is cut out. Okay, I'm going to pass it on to the next one. I think is Risto for the collaborators.
Yeah, there are a couple of areas here. I forgot to turn on the mic. Make it easier to collect data. So that's the second category. A third one is who to engage. Domain experts, obviously, but also public from the beginning somehow. So make sure that we are not hiding ideas and we are communicating with the public all along. I think that's a great idea. And then in order to do that communication, we have to develop a common vocabulary, at least be cognizant that there are different vocabularies, so we can do translations to different stakeholders and adapt the message so that they are actually, it's expressed in their terms. Otherwise, we're not getting through. And then there was the last comment, if it doesn't work, kill it. Okay. Well, that's not bad, actually, because sometimes you invest so much into something that you can't let it go, even though it's not going anywhere. So be realistic. So that was the collaborative stakeholders. Many of these are messages or ideas that certainly were new to me. So I'm really, really happy that we came up with them. Okay.
And on the technical challenges, we had a few votes for visualize and explain uncertainty. And actually, there are a few other post-its about uncertainty. There is also data uncertainty. and model uncertainty. And with model uncertainty, we have correctness and explainability. So I think that's one clear theme, one clear challenge for the technology. It's the uncertainty in the data and in the models, and make sure we understand what the models are doing. Another challenge is to define a reusable project template. We have a lot of use cases here, so it would be nice to be able to come up with a single template that could be reused for all of them. A challenge is in data as a commodity in exchange of usability. Then we have conversational AI on data, on database to provide data, reports, explanation, insights, and QA on data. So I think that's a new challenge. We have some new tools that can provide some new user interfaces. That would be good to use them. But one of the risks is the over-reliance on generative AI interfaces. Yeah, because we know that generative AI can be wrong sometimes. We have continuous updating of the models. That is indeed a challenge. The latency, I'm not sure which latency we are talking about. Maybe the latency in the
maybe between collecting the data and getting to usable models, that would be.
It could be that. So yeah, latency between developing the models.
That was actually me. It was something where, and I mean, we might be quite atypical here in low bandwidth stuff. Like it's the speed between us pressing go and the users getting the answer. Right. Because if they've got to wait longer than 5 to 10 seconds, we've lost them to Facebook, you know, so.
So there is this latency, yeah, at the UI level. There's also the latency between the moment where the actions were taken and the moment where the outcomes could actually be observed. We talked about that with education, where it can take a lifetime to actually understand whether the changes made to the education system were useful or not.
20 years.
20 years, yeah. We have a challenge with the complexity and the interdependencies between all these objectives. We know that optimizing for one objective can have undesired consequences on some other things we don't measure. And we also have consider local context. Connectivity, accountability, yeah, access to compute capacity and tech infrastructure for developing countries, and yeah, that's a challenge. And maybe it's possible to learn some countries and we use the model on some other countries to train the data on some countries and use them for other countries. But we have the bias problem to be careful of. And lastly, subsidized compute access and cloud credits. Yeah, that's also a challenge. That's all, I think.
Yeah, we also had the other category, other ideas. There are a couple on the generative AI, the Explorer no code. And also make model cards accessible to lay people. I think both of these are in the same category of trying to make things more accessible and more explainable and more transparent. I think that's really good. And we have the technology with generative AI to use it for that purpose. So it's not just us researchers playing our own game, but again, communicating with public in their terms. And then there was the idea to engage more startups. That's also a good one. Don't know exactly how we could do it, but that's something that hasn't come up before. And there might be startups who contribute, or there might be an opportunity for startups based on what we build. So something to consider.
All right, thank you. I think that's pretty much wrapping it up. Just real quick, wanted to thank everyone for participating actively. I bet that if you're like me, once you walk out of here, you kind of go, oh, I had this other idea and I forgot. So please send your ideas our way. I would like to ask our ITU colleagues to give us a means for us to stay in touch beyond neural networks. I don't know if there's anything you want to share, on that, Martin.
Sure. I mean, if it's okay with you, we would look into the registration database, who all picked up their badges this morning for the workshop. And we would just send an email. What we would usually do, so I would talk to the presenters that we put all the presentation material on the workshop webpage. And perhaps what we have collected in addition, the write-up, that we would make it available through the webpage as well. So maybe as soon as we have that, I would send an email to all the people that picked up their badges this morning. Okay. And that would then maybe help you to stay in touch or reach out, to one or the other.
Wonderful. Yes, absolutely. Thank you very much. And also that actually brings me to the volunteer scribes that showed up. Thank you so much. It was kind of last minute and you guys persevered through the day and took copious notes. We're going to take your notes and discard them and just have GPT-4 write something up. Anyway, we will definitely take the notes and create a summary of the findings. I, for one, learned a lot from the workshop, so I'm really looking forward to that report coming out, and we will distribute it, as Martin said, through the email list. Also, I really, truly can't read my own handwriting. Okay, whatever. Would like to thank ITU for hosting us. Amir was running 2 workshops at the same time, so he couldn't quite be here. Hopefully we'll catch him at the networking right after. But thank Amir again to be a founder and energy truly behind this project. One thing I want to do is just flash the slide at you guys. And you can't, can you see it? Okay. We need volunteers. We need people like you. If you can join us, that would be awesome. If you know people that can help us with some of these functions, that would be great. Project Resilience is an open project. It's an AI for Good project. What you saw demoed by Olivier was done through volunteer work by people who set time aside from their after work or weekends to put that together. And we need more. We're on a track. We know what needs to be done. We know we have action items. We have a GitHub repository. We just need folks that can come together and help us continue this, continue building out this particular use case, but hopefully also start off on some of these other ones that were your own ideas. So we have a meeting that takes place every other Friday at, is it 8 a.m.? 8 a.m. Pacific? Yeah. If you are interested, once we have the emails going around, we'll ask you to sign up and we can add you to that meeting invite. It's open to all. And the meetings also do get recorded if the timing doesn't quite work for you guys. But very, very much would like to invite you to help. I know some of you guys are in organizations that are already working on decisioning, and we'd like to hear from you. And by participating, you also not just to focus on things that might be more interesting to you. So don't be left out. And then yeah, I think that's about it.